All right, good morning, good afternoon, good evening, depending on where you are in the world. This is CS50 on Twitch. My name is Colton Ogden, and I'm joined today by
Rodrigo, Daboin, Sanchez.
And Rodrigo has joined us before on stream. Well, he joined us yesterday. While we were doing a little bit of Minesweeper, and it's sort of tangentially related to today in that, today we're covering a game, right? So what are we talking about today?
Today's game of 15. So if you were here yesterday, you would have remembered us showing the little visual of what it looks like when it's solved. But yeah, we'll talk about it and throughout the whole stream, and it's essentially just what is a board game in a physical form, but we're doing it terminal based, so just printing out onto the terminal, and you're just trying to unshuffle a board of numbers so that it goes from 1 to 15 with an empty slot at the end, and we'll see what that looks like.
The first time I think you were on stream, was it for Super Mario Brothers?
Yeah, I think it was for Mario. So I've been on stream twice just playing games. Figured I had to come on and actually do something.
That was Zelda, right? You also did Zelda with us?
I did Zelda as well.
Yeah, we did a couple of streams last year towards the holiday season. We ended up doing some actual, proper Twitch content. Normally people play games on Twitch. We program games on Twitch often. Why don't you tell people about your experience at Harvard so far, what you're studying, how long you've been here?
Sure, yeah. I'm a junior right now, about to start spring semester, and studying computer science, kind of a newbie in the field because for the longest time I thought I was going to do math. And then when I was, in my freshman year, actually, the beginning of my sophomore year, I realized I didn't really like math as much as I thought I did. And CS instead was kind of related to math while still, more entertaining for me. So I switched to that. And I'd had just a couple of years of experience with CS before that, mostly with Java, Mathematica, and so I just took CS50 as a freshman, and here I am 2 years later, working for CS50. So.
Awesome. Well, it's good to have you. You also worked with me for the games course.
That's true.
You and I worked together. We taught the games course last. You were in during the summer version, correct?
Yeah.
Yeah, not the spring version. And that was awesome. Yeah, that was really cool. Some folks in the chat, I think, are actually taking the games course online right now. One of the person's named Adamantium. I'm not sure if they're in the chat at the moment. Let's look at the chat, actually, just make sure we're caught up with everybody. So we have Harvey Nato from Brazil. So hello, Harvey. Good to see you.
Bom dia.
I'm not sure if Harvey's been in the chat before, so welcome if this is your first time. Oh, indeed, yeah. Now they're a first-time follower as well as of a few minutes ago. So Harvey, thank you for the follow, and also Taser HD, thank you for the follow. Chat works as Andre Bellacure. Saka Meep, hello from Germany. Hello, Saka. Good to have you with us. That's a new name as well. Edwin21 says hello. That's a new name. Whipstreak23, Nate, hello. Thank you for joining us today. Ziad Monip, hello from Egypt. A lot of new names today. A lot of representation around the world, which is great. Love it. Andre's very kindly giving everybody a hello. Bavik's not here. Oh, that's a good point. Bavik's not here. That's unfortunate. Hope he joins. I did realize that we forgot to post a pub yesterday. We pubbed today. We didn't pub this one yesterday, so hopefully that's not the reason why. If so, that's on me, so I apologize for not doing that. But we mentioned it on stream before, certainly, and then again, in case I do forget, which I won't, about tomorrow David's doing a stream on Render 50, so tune in for that one for sure. And glad that all of you are here today that have tuned in right now. See who else we have. We have For Sunlight. Hello, For Sunlight. Bella Cures, Twin Tower Power. Are we going to get to see Rodrigo bless us with his knowledge today? Why don't you answer that question?
It's knowledge is a funny thing. No, yeah. We'll get to see a little game that is actually inspired from a previous CS50P set, but it was coded in C, and so I decided to do it from scratch in Python and implement a solving algorithm for it. So. It's inspiration from the old, but some of it is from scratch from me, so we'll see.
Yeah, we've done Game of 15 historically, but within the last couple of years, I'm not sure if it's the last 2 years that we haven't, or just the last 1 year. I think it might be the last 2 years. We've switched it out for music and something else this last semester.
When I took it as a freshman, that was the last year that we had it as a P set.
Okay, was that 2 years ago, 3 years ago?
Yeah, 2016.
Okay, so the last 2 years we haven't actually done it. But it's nice to bring it back. There's a lot of, you can go into old versions of the course on YouTube and whatnot and see that course, that problem set existed. Will the stream with David tomorrow be at the same time? I can tell you right now. No, tomorrow the stream is going to be at 3 with David, so tune in for that one at 3 p.m. Harvey hello. Who's from Brazil? For Sunlight, I'll try to listen only. Everybody study computer science. Martian Mars Boy says yes, and that's a new name that I don't think I've recognized. We should make a group on WhatsApp, says Harvey Nato. Everybody's super enthusiastic. Tuxman29, thanks for joining. And oh, there's Bavik at the bottom. He's here. He was just a couple minutes late. Well, I shouldn't say a couple minutes late. A couple minutes later than everybody else. We haven't actually started the implementation yet, but glad to see Bavik there as a regular. And Tuxman says studying CS in Montreal because of CS50X. That's awesome. Cool. I'm going to bring us to the shot of your computer, which is just at this moment an empty terminal. And I'm going to sort of let you take control at this point and sort of guide us through what you want to illustrate. So go for it.
All right. Well, let's just, for those who are not familiar, actually, I can do this from the terminal now. So if I write a bunch of just random things in the terminal that you haven't seen before, I like aliases a lot. And so actually I can...
so GC for Google Chrome?
Yeah, I might have some jobs right now, so let me just exit out of that. But if I actually open up Atom here, I have some nice little aliases. So I'm really lazy and I don't like typing things out very long. So for committing it to Git, I have GCM instead of having to write git commit, blah blah blah.
I like that.
So just random things. I don't have to write the same thing over and over again. So
I should probably do that too.
If I navigate pretty quickly in the terminal, it's just because I kind of saved future me the headache of writing all this stuff unnecessarily. But okay, so here I am. What I was going to do is show everyone who hasn't seen Game of 15 what it looks like.
Oh, good idea. And that's a good image on the right. I like that. The 15 puzzle. And some people might know it as 15 puzzle. That's maybe
might be a little bit small.
Popular name.
Yeah, 15 puzzle. So this is what it looks like when it's solved. It's like I was alluding to before, kind of a 2x2, like a 2D array type of thing, where you have 16 empty tiles, and then 15 of them are filled up with tiles numbered 1 through 15. And so what you're trying to do in the physical board game is just kind of, they don't start off solved like this. They'll start off in some scrambled way, and you're trying to move the tiles, down to the left, up and right, so that you end up with this configuration. And we're going to do this on the terminal. So that's about it.
Tuxman says, I also teach intro to coding to kids, and a phrase that they always use, coding is the art of being lazy.
Exactly. I always tell everyone, being lazy is the best feature a programmer can have, as long as they still get their work done.
I kind of agree with that. Rabin Gare also says hello there. So hello, Rabin. Good to have you with us. What were you going to say?
Yeah, because being lazy makes you look for the most efficient solution, the one that takes the least amount of work.
There's that quote from Bill Gates. It's like he'll always choose the lazy programmer or whatever, the lazy worker, because they'll get the job done with the least amount of work.
Right.
I don't know if that's actually a real quote. I feel like I hear it all over the place.
So what I'm doing right now is I am just creating.
So touch, to be clear, is
right. So right now I've just created 2 new files using the touch command. And it just creates, an empty file for you. You give it the name, and so here it is now in my text editor, which is Atom, which is a different one than Colton uses. I don't remember which one.
Yeah, I use VS Code, but they're very similar. They're sort of Electron-based modern text editors with a very well-supported plugin system, plugin ecosystem. VS Code has some built-in debugging stuff, which is pretty cool.
That's nice.
Virani's in the chat saying, hey guys, been here yesterday, decided to stop by today as well, so thanks for popping in again. Glad to have you with us.
For sure. And I know we don't do a lot of Python coding on the stream, right?
Not yet, at least.
Not yet.
It would be nice to do more of it, I know that for sure. A lot of people are into Python. I love Python. I don't use it in the context of game programming, but yeah, absolutely think we should definitely have more Python stuff. So this is a good step in that direction.
And so, with Love 2D, which is what Colton usually uses when we're creating a game, you have kind of the, the update and the render and the load and everything. But with Python, you don't get that kind of built-in behavior. You kind of have to implement it yourself. And so, in Python, if you want to do something as simple as printing hello world or just hello, you literally just write it in kind of whatever file. Usually it's called main. And then if you run it here, you would write Python 3, but once again, I'm lazy, so I just write Py. And that's how you execute, a Python program. So, all of a sudden, we have our first Python program. And before I kind of jump into the actual coding itself, what I like to do is kind of build myself a little roadmap. So what I'm going to do is create another file called plan.txt, and I just like to kind of write out what I need to do to implement the program before I just dive into it. That way it's kind of like writing a rough draft of a paper before you, or an essay before you dive into it.
Yeah, absolutely. I do that too actually a lot with when I'm working on a larger project than like some of the ones we've done on stream. Like something that's maybe more representative of a real world sort of game code base. It's very easy to get lost in sort of like figuring out where you want to go next. So having some sort of to-do, I mean essentially it's the idea of just a to-do list.
It's a to-do list,
general.
basically.
Yeah. I mean like we use Asana for like work, which is a great tool for to-do list stuff. And it's that sort of idea, you know, people that can keep track of all the individual things they do, I feel like it's easier to stay on top of stuff.
So I'm just making a checklist here, things that we need, and if we, oh, I got rid of the image, didn't I?
Fancemaker is saying, dude, I have a huge Excel table and I have to crush it down for work. I'm using Python since I suck at Excel, and Python also, but still Python is pretty comfy.
So if we're kind of taking a look, oh, what was that?
They're saying they have a huge Excel table and they have to crush it down for work. They're going to use Python instead of Excel because Python's like pretty nice.
Yeah, Python gives you a lot of flexibility, and David teaches a class at the business school that, you know, starts off in Excel, then talks about database languages, and then moves on to Python, and it's just kind of like, you know, the different things that you use these tools for, and obviously Python gives you a lot of flexibility. So, but yeah, so if we're looking at this board right now, and we're thinking about if we're writing a video game version of this, what do we need in order to code this? The first thing that comes to mind is, well, we actually need a way to represent the board, right? And so I preemptively created a file called board.py. But in the plan, let's just kind of jot to ourselves, we're going to need a 2D array, probably, to represent the board. And then we're going to be obviously moving it around a lot as we try to solve the game, and we should ideally keep in mind an image of what, you know, the game looks like when it's solved. So maybe we're also going to need a 2D array to represent the solved board or the goal. All right. If we take another look at this, we see that there's always going to be this empty slot. And as we shift tiles down or right to the left, it's kind of moving around. So it might be useful to keep track of the position of this empty tile. So if we think about a 2D array, this might be position 0, position 1, 2, 3, and then this is, you know, row 0, and then this is row 1, position 0, 1, 2, 3. So we'll probably want to keep track of this empty slot, because if we think about how we're going to implement shifting tiles, what we'll probably want to do is just swap the location of, you know, the empty tile with the tile in the direction that you're trying to move. So it'll be nice to have a reference to that position. So we'll need a location variable to keep track of empty tile.
The chat's curious about your distro of Linux, by the way. Do you want to share?
Oh yeah, I have LSB release-a. Ubuntu 18.10 Cosmic.
Nice.
And I actually have to give it a shout out to one of my coworkers, Kareem Zidan. He helped me. I was actually using Windows before, and I wasn't very familiar with the Windows terminal. And what I had to do instead was download a bash subsystem that ran Linux on Windows, and it was, you know, nice for a while, but it's still kind of growing, and it hasn't, you know, implemented all the features that it needs. So some things that I wanted to run on it didn't work, and eventually I decided to dual boot my computer. So this computer is actually running Windows and Linux, but separately. And so when I shut it off and turn it on, I can pick which operating system I want to use.
That's pretty cool.
So yeah, it's pretty nice. I can program in my Ubuntu, and then if I want to do, you know, like Microsoft Word or whatever, I can switch over to Windows. So, you know, that's nice. So where were we? Yeah, so we're talking about things that we need. We'll probably want to be able to see the board somehow. So we want function to display board on screen. Let's see, what else do we need? We probably need, if we want to make moves with the keyboard, we'll probably need some sort of listener for keystrokes, which remind me, does that come built into Love2D, right?
It does. Yeah.
It does? Yeah.
Love2D has a function called love.keyPressed, which is a callback function that Love will trigger. There's a hook in the executable that is always polling for input, and whenever it gets any key stroke or any interface, mouse, keyboard, joystick, whatever, it goes through all the callback functions that you've registered via love.keyPressed. Well, so it goes through all the callback functions it has registered and then calls the logic you've defined within those callback functions.
Yeah, so that's pretty nice. In Python, when I was tinkering around with the idea for this game, I actually realized that I was going to have to download a library in Python to help me keep track of like a keyboard listener. So we'll have to take a look at what library to use for that. And the game's not too complicated. So basically, the last things we'll likely need is just if we want to solve the game, maybe a function to solve the game. And then how do we know that we're done? We probably want some sort of game over screen or something. And I think that's a pretty good starting point, right? This is a nice little to-do list. We can kind of knock these out one by one.
I usually do my game over screen like ultimately very, very last, once I'm on stream at least.
Yeah, I mean, it's not really like a functional thing that the program needs, but it's kind of like a nice, okay.
It's a nice way to like package it up with a bow and be like, oh, here's a game that's actually sort of complete, more or less, or at least feels complete.
Exactly. So, okay. We saw that with Python, essentially you just kind of write things down and you can run it because it's an interpreted language. And so I proposed that we actually start by modeling the board, and let's actually put this to-do list down here so we can refer to it.
So Lancemaker's question is, are you printing the state of the board on the terminal, or will you be rendering images?
So the board will just be text-based on the terminal. Just a simple, as much as you see board.py, main.py, plan.txt here, you would just see like 1, 2, 3, 4, 5, 6, 7, blah, blah, blah. That would be the board kind of like in a square. Just by default, I have it so that when I clear my screen, I have my directory listed, like all the components and stuff. But if you actually don't want that, you can have that gone too.
Quite a bit easier to like start implementing something like that too, compared to like making all the artwork you would need to make otherwise.
Yeah, we saw yesterday how long it took to make sprites and stuff.
And those are simple sprites too. And then, making games like this, you can focus more on the gameplay so you don't have to spend as much time on the resource development. Like games like roguelikes, for example, are very rich in terms of what you can do with them, but they're ASCII art. So they're, they sort of take one thing, put no emphasis on it, and then put a lot of emphasis on everything else. It's kind of like pros and cons,
So what I'm doing right now is I'm just creating a class, and we briefly talked about that yesterday.
We've mentioned object-oriented programming. Yeah, we haven't gone into tremendous detail on the mechanics of it, what inheritance is, what polymorphism is.
Essentially, what we said yesterday was that writing a class is kind of like writing a blueprint for something. So if you want to represent an object, in this case, we want to represent a board. So we want to have some sort of idea in code of what a board is. We can envision that, things that a board can do is, make moves, render itself, kind of, randomize itself, check if it has, matched goal state of some kind, if we want to attribute a function for the board to solve itself. These are all things that a board should be able to do. So what I'm doing is I'm writing a class to kind of make the blueprint of what a board is and what, properties it might have and what methods or actions it can take, etc.
Essentially lets us define a new data type, where that new data type is, instead of being an integer or a string, it's something that's a little bit more representative of something we might find in the real world. A board, for example. There's no, in computer science, there is no sort of intrinsic data type that is a board, but we can define, roughly speaking, in an abstract way, the different pieces of information and the functions that we might associate with a board, sort of lump them together so we can think about boards versus the numerical information we would need to have a representation of that.
And so I was kind of typing a little bit while you were explaining, and this is touching on what we were talking about yesterday about the constructor, which is different syntax and Lua, but essentially when you create a board, you define it as a new data type, and you actually want to, like in Python, there's such a thing as an int, I guess, a number. And there's a difference between the theoretical existence of a number and then actually having the number 4, like writing x equals 4 or something. So we can have this blueprint of what a board is, but then we actually want to create one. And then when we create one, we want to attribute properties to it, and so that's what the constructor is going to be doing. So this kind of maybe a little bit foreign syntax, def underscore underscore in itself, is essentially the syntax for starting to define the constructor in Python, where self is just referring to the board object itself. And so what we were referring to here in the plan is that we need a way to represent the board and solve the board. So the goal, so the solve state, if we want to have it look something like this, I propose making like a 2D list of some kind. And since we know that we want to print the board onto the terminal, I'm just going to go ahead and make the numbers just strings. And the nice thing about this is that I can preemptively put a space between a number, because I know if later on I'm going to have a number like 10, that's going to take up 2 kind of like character positions, whereas if I have single-digit numbers, they're not going to be aligned in the same way.
Right.
So I'm preemptively trying to make sure that they line up by keeping them in text.
That's cool.
So yeah, this is me creating the board right now in the solve state.
And much like creating sprites. Speaking of that, Ronnie was saying those sprites yesterday, Slytherin too. Because remember the snake, the 2 look like a snake.
Oh, yeah. That was funny.
NACL Eric, have you played Dwarf Fortress? I have played Dwarf Fortress, not a lot though. It's got a pretty tremendous learning curve. Have you played Dwarf Fortress?
I have not.
Have you heard of Dwarf Fortress?
Most of the games I play are very few in number.
Gotcha.
I play
That's
FIFA
a nice way of saying no.
Yeah.
That's a very political way of...
I love games, but I don't play them that often.
Yeah.
Well, that's a lie. I play the same games a lot.
Are you familiar with roguelikes? Do you know what that is?
Actually, would you want to explain?
So if I can, I'll show you an image here on a separate laptop. So images.google.com. So this is what a roguelike looks like. It's kind of like, have you ever seen an image like this? Looks something like that?
It kind of makes me think of, what's it called? Everyone plays it nowadays. The World of Warcraft or something like that? I don't know.
Yeah, not quite. Or like this, where everything's kind of looks like ASCII artwork. You've seen the games like that?
This is all new to me.
Oh, okay. Well, we can maybe talk about it another time. Dwarf Fortress is a type of roguelike, sort of, but it's a much deeper roguelike than most roguelikes are, and much more flexible and much more catered towards like building things. But yes, to answer NACL's Eric question, I have played it only a little tiny bit. A class is a struct on steroids, says Andre. Yeah, in a sense, kind of. Depends on the language, I think. Bavignite, why not use loops? I'm guessing we probably are going to be using loops at some point.
Yeah, they're probably referring to me making this board.
Oh, yeah.
I'm just like, yeah.
That's fair. Yeah, you could do it with a loop, I guess.
I'm only ever going to have to do it once.
This kind of, you visually can, if you're a programmer, you visually can see, there's a point to be made about visually being able to see exactly what the data structure looks like. And so I actually agree with this decision to draw everything out with strings. It's just a lot more readable.
It kind of helps me visualize, like now I can see this is the shape of the board.
One thing I probably would do is I'd probably do that, just because then it's perfectly aligned.
Yeah, that's true. So and it's like especially because alignment is important in Python. It won't care about this so much, but like if I don't have this indented properly, it's not gonna.
Yes, the important thing for those new to Python, indentation is crucial. You absolutely need layers of indentation to let the interpreter actually work and run your program.
Questions in the chat?
No, I don't think any. So Dunder Proto, anyone here got the reference? I'm not sure what that is a reference to. And then MOBA games, Ronnie was asking. I used to play League a bit and Dota. Have you played MOBA games at all? League or Dota?
League of Legends is what I was thinking, not World of Warcraft. No, actually.
Oh, I got you. Okay. Yeah, a little bit. Too many games in the world. Way too many games.
So what I'm doing right now, I created this, solved state for the board, and what I did after that is I imported from the copy library this method or this function called deep copy, and the whole point of that is I know that the board is ultimately going to get shifted around, and instead of writing this all over again or doing a loop, I just essentially figured I would just make a copy of the goal and then shuffle it later. Because if we think about this game, it's not necessarily going to be solvable from any configuration of the board. So the way that I want to solve it is I want to start from a solved state and then make, I don't know, like 100 random moves in any direction. That way I know I'm starting from a position of a solved board, making legal moves only, you know, shuffling the board that way.
Right.
So in order to do that, I just want the board, which is going to change eventually, start off being in the same configuration as the goal. I don't want to change the goal because I'm going to need it to compare whether the current board is the goal. So that's why I'm making a copy. And the reason I'm using the deep copy method is because what it does is it recursively copies lists that also contain lists, for example. So
just saying self.board equals self.goal would just make a reference, basically a pointer to self.goal, so any changes to self.board.
Exactly. If I do something like this, what Python is going to understand is that these two variables are referring to the same
data structure.
The same data structure.
Memory, yeah.
So if I change one, the other one will be updated as well. And I want to avoid that. So I'm basically making a separate copy of the board from the starting position of the goal. And I'm making sure that I'm avoiding the issue of having only references to the lists within the list by doing this deep copy, which recursively makes sure that I copy everything.
That's very smart.
Then I'm also starting to track the location of the empty space, which I have, you know, just chosen arbitrarily to denote with these underscores. And I know this is 0, 1, 2, 3, and then this is 0, 1, 2, 3, so column and row. Maybe we can have something like, you know, max call and max row.
Rabin is asking, deep copy should be inefficient, right?
Maybe with like a very large data structure, but this is so small that I don't think it's gonna really make a difference.
Yeah, this is a tiny data structure. Like making 1,000 copies of this data structure you wouldn't even notice any speed change probably. But if it were hundreds of thousands of rows in a database type data structure, then yeah, I could see that being very inefficient.
This actually semantically I think is backwards. Max row, comma, max call. And I am going to go ahead and have these constants be, well, they're like, you know, constant, be equal to 4, even though I know the index is 3, because I can imagine myself wanting to loop things repetitively from, you know, 0 to 3, and with the Python range function, you know, the parameter that you pass into it is not inclusive. So if I pass in a range of 4, it's going to give me 0, 1, 2, 3. And so it'll just be nice having, you know, these constants for semantic purposes.
The last CAC was saying, I want to just Control-C and Control-V, probably referring to self.goal, self.board. Pretty fun.
Oh, yeah. You know, that would accomplish the same purpose, but programmatically, it's not necessarily great design to just copy and paste.
Dry principle.
Yeah.
Very important.
It's you know, it's more of a me being a stickler kind of, and so we won't worry about this yet. Not jump into the moves just yet. Okay, so we have an array to represent the board, an array to represent the solved board.
Last CAC, we know you're joking. We're just messing with you too.
Let's see. I maybe just want now to make sure that everything's working so far, so I may want to wait to print this to the screen. And Python has another one of these funky class class names called repr for like representation. Like how do I want this board to be represented if I like print it or something? So, you know, it's just a list that contains lists. So I can imagine doing something like, you know, for I in range of the max number of rows, for j in range of the max number of columns. Then I want to just print, well, print, we called this self.board at positions I and then j.
Often you'll see yx, xy for 2D data structures as well.
True. Yeah, you know, we can do that. It's the same thing, but whatever.
It's fine. IJ is also fine.
Then if you notice, if I just open up the Python interpreter right here, if I print, you know, something as simple as hello, I kind of get knocked down to the next line. But if I include this additional parameter called end, which denotes what I want at the end of the print statement, by default it's a new line. You'll see that, you know, when I didn't have it, it kind of knocked me down one peg, and here the prompt is the same in the same line. So if I know I want to print the column side by side, then when I'm iterating, probably don't want that new line behavior by default.
Oh, Ronnie was mentioning you have spaces in these double-digit numbers here.
Oh, that's true. Thanks for keeping on. That would have been fun to see after we printed it.
Yeah. That one's fine. The 9's fine. You can put a space there.
Good point. Okay. So
thanks, Ronnie, for mentioning.
Thanks for looking out. Yeah. Sweet.
Arrowman was asking, just join. What are we doing today? We are doing Game of 15, a prior CS50 P set, but we're doing it in Python. Traditionally, we've done it in C at the command line. And then Rabin's saying in JS we call the sort of the prototype methods with underscores dunder methods. So they call those funky methods dunder repr, dunder init, etc. I have heard that as well. Yes.
So I'm returning an empty string here because the repr function by default must return something. And so, you know, I'm not going to store this value anywhere. This is just if I don't include it, Python will complain. Okay, so right now we have a board with a goal, an initial starting board, and then we have a way to print this. So in the main screen, let's just do something like, you know, b equals, we're probably going to have to import this. So from board, which is the name of our Python file, from board we want to import. It's this kind of funky syntax because the file name is called board.py, and so this is referring to the file name. And now what I'm importing is referring to if I want to import any methods or classes or whatever, we have a board class. So we're going to import the board class. And then here we can do something as simple as b is set to, we're going to define a board, and then we can print b if we want and see what it looks like. All right, unless I screwed something up. Let's see what happens if I run main. Name goal is not defined. Oh, LOL. So that's what the self keyboard is for. This is called self.goal, and I just put in goal. So thanks, Python, for watching out there. Okay, so interesting. We have 1, 2, 3, 4, 5, 6, 7, 8, and now these are kind of, you know, jammed together. So we might want to put some spaces in between these.
Airman was asking, what terminal is this? I'm new to Python, so can you suggest where do I get this terminal or platform where you are writing this code?
What terminal? Oh.
Or platform.
I configured my terminal, so by default it didn't look like, it wasn't, you know, purple and stuff. But in, let's see, do I have my other, where's my, here we go. Come on, Adam. Not highlighting.
I mean, what we can probably say is that it's terminal with a specific bash RC or bash profile or whatever. I forget what it is that customizes your command prompt and you're on. We talked earlier 18.10 or 18.08 Linux or Ubuntu Linux, something like that.
Yeah, I'm on Linux Ubuntu 18.10, and so there's like the bash bash RC file that helps you customize all this. And so, you know, I wanted different things to be in different colors, so I knew. So like the name of my current directory is in blue, and then you know, my username is in green. Everything else is in purple, and if I'm in a GitHub repo, it'll show me the branch I'm on in yellow. But you know, maybe that's a topic for another stream, how to customize a terminal or so.
Ronnie's asking, is self similar to this in JS, JavaScript?
Is what?
Is self similar to this in JavaScript?
Oh, yeah, it's similar. And oh, that looks a little bit better. In Python, the whole point of it is that, this is the wrong, let's just close this. In Python, the whole point is that if you're in a class, the class is a blueprint, and so let's say we have a blueprint for a house. The house itself if it has some things that it can do, it's going to refer to itself using the self keyword. You know, the typical example for classes that I've heard used is like a car. A car should have like a color property. It should have functions like it can drive, it can brake, it can do all these things. And so when you're writing like a class that maybe is going to represent a car, you can say like, you know, self.color, because if you instantiate multiple cars, you can imagine you want one to be red, one to be green, one to be blue. So the self kind of emphasizes that you're talking about the current instantiation of the object.
This is a bit weird in JavaScript because, I mean, I haven't studied this in a while, but like, for example, every function has its own this scope. So it's a little bit weird if you call this within a function that's within an object. This is actually the function and not the object. I believe that's the case. I ran into this issue fairly recently, and the chat was talking about how they're having issues with this in JavaScript. And yeah, it's a bit weird in ES5. The self in Python is much more consistent and I think easy to understand. But yeah, not arrow functions. Yeah, arrow functions don't have that problem. Yeah, that's correct.
All right. So far so good, right? We have a 2D array to represent the board. So maybe we can get rid of this and put this over here, something like things we have. And then we have, you know, a way to represent the solved goal. So let's put this in here as well. We have this location variable to keep track of the empty tile, although we haven't used it yet. We have a function to display the board on the screen. Okay, so this might be a reasonable time to look for a listener. And what I'm going to do right before that is, you know, you can have the main or whatever Python file that you want to run. You can have it run just kind of, you know, without having to do any main methods or anything like that. But it's annoying if you want to have different functions that run at different, like at specific times, because anything that you have just kind of like in that outermost layer right here is always going to run by default. And so if you want to wait to execute some things, it might be, you know, favorable to put it in a main function. So what I'm going to do for now is I'm going to just create a main function, def main, and then all it's going to do for now is print the board, I guess. I want the board as a global variable for now in case I want to refer to it outside of the main function at some point. And then if you have a main function, you have to, I mean, you can do something as simple as calling main right now, but the convention in Python is to write this more cryptic looking statement called if name equals main, then run main. And what this does is essentially if you're importing this file to a different file, so if this is going to be a helper file for some reason, it won't execute the code in that one. And if you're just in this one importing other stuff, it knows that this is the main file, and so it's going to call the main function. But you know, we usually just wave our hands at the syntax. All we know now is that this should, in theory, accomplish the same thing as before, which it does. Okay, so now let's look for a keyboard listener. And the one that, you know, I was toying around with is called py input. And this is for those who may not have ever heard this before. I wanted to kind of point at the documentation. But it's just this small little library that supports listening for the mouse and then listening for the keyboard. For the purposes of this project, I guess we're not going to be doing much with the mouse. But it does have a way to monitor the keyboard and control the keyboard. And then it, you know, handles errors and such.
Lasskek says, gotta go. CS50 TV, love the stream. Cheers. Thanks, Lasskek, for joining us. See you on the next stream. Andrew was saying JavaScript's this is a bit strange. But yeah, it is. In ES6, they made it a little bit more, I think, consistent with other programming languages. And to Andre's point, in C-like languages, like, for example, Java, this is a bit more like self in Python. And then Aerospace Man, or Arrowman123 was saying, I'm working with a supercomputer in Barcelona running aerospace aerodynamics and CFD simulation using OpenFOAM. And then people were saying, oh, that actually makes sense. That's why your name is Arrowman123. JS is lexically scoped, but when you want something similar to dynamic scoping, this gives us that. On arrow functions, there is no this defined on the scope, so it goes up the scope and attaches itself with parents this definition. I'll have to reread on all that for the JS stream that should be coming up in a couple of weeks. And then Pudavidotel was a new viewer from yesterday, says, hello everyone, tomorrow there will be a stream, because today I will not be able to be on this wonderful channel. Well, I hope you can join us for tomorrow's stream. Glad to have you with us. Yeah, I think we're caught up.
All right.
So and then while I was doing that, you programmed the...
well, no, it's, you know, in the documentation they have, hey, if you want to, you know, control the keyboard, for example, this is how you press and release keys or whatever manually. But if you just want to listen for the keyboard, you know, you just copy this code. You have to import the library. I think I don't think it comes by default in the terminal. I think I had to install it with pip. And then once you have it, you can import, you know, the keyboard method. And all that it has is like kind of similar to Love 2D now, where you're listening for when people press keys. It has, you know, a method that fires when a user presses a key, and one that fires when they release that key. And here's kind of the actual like listening portion. And if you kind of read through it, you see that you pass in the methods that you're going to be using. So they're going to be using an on-press and on-release. And what I did was I just kind of put this in our file where I imported from py input the keyboard function. I defined the on-press and on-release key exactly as they had in their documentation. And then in the main function, in the main method, I you know, started the listener so that it's constantly listening. And
cool. As basically it takes the place of like a while true.
Yeah,
kind of.
yeah. And the only other thing is that in the documentation they say the way you can stop the listener, you can pass it some, you can like basically broadcast some special codes, but more simply you can return false. So in this default behavior that they have here, if what the user pressed was the escape key, they just return false. And so if we want to just run their code and see what that looks like, I press enter to execute the file and the program, and it's realized that I press enter. So if I press up, the terminal has this kind of annoying behavior where if you press some keys, it gives you this annoying thing. But here's their feedback. Key.up has been released. If I press A, alphanumeric key A is pressed, and the terminal has this annoying echo. So we're going to want to silence that during our program, because we won't want it to display what key we're pressing every single time. But yeah, I can just do something as simple as escape now, and it says escape key has been released. And if we take a look at the code, that is exactly what this does. Is whenever you press a key, it just tells you such and such key was pressed if it was alphanumeric, and then if it was not alphanumeric, it tells you that it was a special key, and it just prints which one you pressed. And when you released, it tells you that you released it, and then if what you pressed was the escape key, it kills the listener, which basically terminates the program, because that's the last thing happening in our main method. So yeah, now what we want to do is adapt this so that we can essentially have moves that we can make in the game.
It's kind of like Love 2D, like you were saying. It gives you the ability to like check basically. Oh, it's constantly looking for input, sort of almost like behind the scenes. But in this case, we actually define that behavior. And then if you press, if it checks for the specific code, and if the code is equal to escape or whatever, you can decide to quit the game or do some sort of movement to change some value of your data structure to actually make the game playable. And also, thanks Pudavidotel for the host. Much appreciated.
So now we can basically just get rid of some of the stuff that they were doing. And then, I don't know, here we want to do something, I guess. So we can print, hello for now, just as a placeholder. And what we want is whenever the user presses the escape key, that seems reasonable to want to stop the program. So we'll probably want to be listening. If we look at the board, we imagine the empty space is kind of what we're going to control moving around. let's say that we want a behavior where if we press the left key, the empty space, swaps with the number to its left. So here we would swap with 15. And then if we press up, it goes to 12 and so on and so forth. So we haven't actually implemented moves in the board yet, but what we can do for now to make sure that this is working is just print like left or print up and right to make sure that we have something working. So
sanity checking.
Right, sanity checking. So right now I'm going to say if keyboard.key up is pressed, I'm just going to print up. And then even though ideally you're not supposed to copy and paste code, sometimes you just gotta.
Who suggested that up above? I forgot who that was. That was that was the Keck, the last Keck who did that, which is funny.
And here we go. So in theory now, if we press up, right, down, or left, the program will tell us what key we've pressed, and then later on we'll replace this with actual behavior of moving in the board. And
it is an important step. Make sure that you're actually checking for the right things, that it's triggering that, sort of like penciling in your application, and like filling in like that your sketch with the actual color or the actual paint or however you want to analogize it. But we do that even when we program games typically on stream, like a typing game. We do that. We put all the labels and all the text everywhere with like mock data. And this is something like people in like web development do a lot too. They'll make a static, if they're like trying to make a dynamic web page, they'll put everything that's like static, like kind of that would represent what the website would look like ultimately, and then actually flesh it out with the JavaScript or the the Ajax or whatever that they would normally do to make it actually truly dynamic or whatever.
Did I miss anything in the chat or anything?
No.
Okay. Yeah, so far we have what we were talking about before, the annoying echo that we're going to have to get rid of. But we see now that when I was pressing the up key, it was printing up. When I was pressing left, it was printing left. Down, it was pressing down. Right, it was printing right.
Sorry if that was loud. I forgot to mute my phone.
For now, let's go back to the board. And we will probably want to implement, so we have a listener for keystrokes. Now we want a function in the board that will allow us to make moves. So we kind of alluded to this earlier, how we want to create moves is if we're taking a look at the board, if I press left, I'm going to want to swap with the element to my left. If I press up, I'm going to want to swap with the element above me, and so on and so forth. The only tricky thing is, even though this looks like a square, this isn't necessarily a square memory. This is, if we recall how we define this, this is a list of lists. So we will have to be careful with what indices we're adding and subtracting when we do this. But I propose that we start, it's going to be very repetitive if we have very similar behavior for making a move to the left, very similar behavior for making a move up, and the only thing that's changing is whether you're adding to the column or you're adding to the row index. So what I propose is having just a general function for making a move where we're going to have some placeholder variables, x and y. So let's do that. Let's create a move function. It's going to have to take in itself again. Ideally, we could do this in two ways. We could have it refer to self.board every time. But later on, if we want to make a kind of like artificial intelligence solve function that solves itself, that's going to be annoying because we're going to have to search different possibilities. And so if we start off with an initial composition of the board, we're going to want to basically make 4 copies of it because we can move up, right, down, left. And if the move function is always referring to self.board, if we move up, then it'll update self.board for everything. So I propose that we allow a parameter in the move function where we can just pass in whichever board we want to make the move on. And then in the main .py file, we can just pass in the objects board for now. Okay, so we'll also want to keep track of the location of the empty space, and then since we know that the way we're going to swap elements in our list of lists is by adding and subtracting to the indices of the list, we'll want to pass in like an x and a y, like you were saying. Okay, this seems like it should be comprehensive, and if we want to just test out, how does swapping work in Python? If I open up the interpreter again, and I have, usually what you would imagine is you would have something like, x equals 1, and then y equals 2, and then if you want to swap, x to be y, you would have to have like some sort of temp variable, maybe set to 0, and have something like temp equals x, and then let's see.
X equals y, y equals x.
X equals
y. Y equals temp, sorry. X equals y, then y equals temp.
And now y equals temp. And so what this would do is now if I see what x has 2, y has 1. But in Python, we actually don't need this middleman because we can do something as similar or as simple as this. If I have x equals 1 and y equals 2, we can have something like x comma y equals y comma x, which is very, very nice.
You do that in Lua too, which is super cool.
In Lua as well?
Yeah.
So yeah, now we have x having the previous value of y and y having the previous value of x. So that's just how swapping works in Python for those who didn't know. That's going to be something that we'll probably want to do here. And let's just go ahead and jump into it. So we know that we're going to be accessing a board that's a list of lists. So we want board at, and when we move, let's go back here. When we move this tile, we're starting off at the position, the empty position that we have, which we're passing in here. So let's say, and the way that we define the empty position is by default, the board is going to be at 3, 3. This won't matter when we shuffle it, but we were going to have the location of the empty space tracked with this variable. So we're going to have, on the x, it's going to tell us what index in the row it is. So like this is row 0, row 1, row 2, row 3. And in the y component, it's going to have what index in the columns it is. So this is 0, 1, 2, and 3. So we're going to want to refer to the location at position 0 for the x, and then the empty location at position 1 for the y. All right. And this is going to be the empty swap. So this is basically like our first thing. Then the next thing that we want to swap is either the tile above it, to the left, to the right, or below it. So since we want this to be a general move function, where later we'll have something like def move up, and then def move right, and def move down, and def move left, where all these essentially just call the move function with some parameter, some xy. What we'll want to do is, if we're moving up, we will want to add, or no, we will want to subtract 1 from the row position. And if we want to move to the left or y, we'll want to subtract or add to the y position. So we can do this, we can do all this logic of whether it's supposed to be minus or plus and which one is supposed to be in these abstracted out methods, such that so move up would look something like, we would pass in the board and the alloc and then we would pass in something like, if we're moving, you know, -1, 0, something like this. So here in the actual move function, we would only have to worry about adding x and y, whatever they may be, to the index. So this is going to look something like loc 0 plus x. X could be negative or positive. And then loc at position 1 plus y. All right. Now we're running out of space. So this backslash in Python lets us kind of move on to the next line without having to worry about the end of a thought. Okay, so here essentially we have on the left-hand side of the swap the position of the board that contains the empty space. On the right-hand side we have the position of the board that is, you know, some relative distance from the empty space based on whatever we input to be x and y. So if in like this move up example, we're putting in -1 for x and 0 for y, that means that moving up this right-hand side will be the empty location -1 at the same y, which if we look at this, if this is empty location 3, 3, empty location -1 will be, in the x component will be 2, so there's a 0, 1, 2, and then it's the same y component, so that'll be the same, that'll be the 12. So yeah, that looks like we have about right. And so now what we essentially want to do, like we did x comma y equals y comma x, is swap this.
Reverse them.
Reverse the order.
Verani was saying, I just learned how to construct dynamic web pages with Express and EJS templates. That's awesome. We'll probably actually have a stream on that in the near future. After we get past the CSS, JavaScript, Bootstrap, jQuery, all that fun stuff, we'll probably go into Node.js and therefore Express. Bavik Knight, in reference to your temp swap example, was saying the temp equals 0 line was actually redundant, and I think, yeah, because you could just do temp equals y or whatever. Mm-hmm. But I think you were just trying to illustrate that, like, temp, I guess maybe in reference to other languages where we would have a temp variable, I can see you would usually set it to something by default. And then he was asking, can we do nested class within the board, like a class move with up, down, right, left that inherits from move?
I don't remember if you would put it inside. I know you can definitely do inheritance,
yeah.
But I don't recall having seen an example of a class written within a class like that.
I think you can. It's been a while since I've actually needed to do that in Python. I don't think I would do it in this example, though. I don't think abstracting the idea of a move really saves us much.
Okay, so far so good. And then what we did here was we update the position of the empty location, because if we just swapped it, let's pretend this is what we're swapping. We swap, you know, position 3, 3 with position 2, 3. If we move up, we want the location of the empty space to be updated as well. We don't want to, you know, refer to 12 as the empty location now. So we're also adding to the, and this is kind of syntax for like updating something. So like if I open up the terminal again, Python, and then I have, I don't know, x equals 1, I could do something like x equals x plus 1 to get 2, but I could also do x plus equals 1 to add 1 and update it. So now it's 3. So this plus equals essentially means add, you know, whatever it is to it, and then update the value. So what I'm doing here now is making sure I also update the position of the empty space with the x and the y. The only other thing that comes to mind, and then of course I'm returning the updated board and the updated location. The only thing that comes to mind is if we look at this example again, where we're in this configuration, even though it's solved, we could imagine that the user is in a corner, so like the empty location is in a corner, and then say it's at the bottom right corner, the user tries to move it to the right or down, and those locations don't exist.
Yep.
So
we did that like sort of yesterday with Minesweeper too, when we were doing the pre-calculation for all of the nodes.
It would be an easy thing to miss out, like to just forget to code it, and then something breaks. So before we actually do the swapping, we should probably check. And so swap. update empty location. And then up here we're going to check legality of move. You know, hashes are how you comment in Python. So the way we can do this is if the empty locations x component plus x, because x could be positive or negative. So if this is less than 0, or if, oh whoops, you don't have to write if twice. If the empty locations x component plus x is greater than 3, because 0, 1, 2, 3, that is the 4. So if it's greater than 3, or if we have something similar for the y component plus the y is less than 0, or it's less or greater than 3 plus y.
It's arguable that like a named tuple might have been appropriate for the location too. So instead of having to index and a 0, you could just do like .x, .y.
Yeah. We haven't really used it much yet, so we may as well go ahead and do that. We can have this be like, or even a dictionary, right?
Yeah, a dictionary would work too.
Be like row, and then this could be column. And then here.
So now you would just replace every 0 with row or column.
And then this will be easier if I just, yeah, this semantically is probably easier to read as well.
I would have probably done the name tuple with .x, and you could do .row as well, just to save like readability, just because it gets a little bit cluttered here with like all these brackets,
you would have
square brackets. I would have probably just made empty location a name tuple, and I have to remember the exact syntax for it, because I don't find occasion to do it a lot. But there is a, and I don't actually remember if they made it a native 3.7 or 3.6, just like part of the core language, because normally you have to, here it is, name tuple. So you make a name tuple call, in this case you could just call whatever you want, which takes in, and it has an x and a y, like that. And then from every time you want to do that afterwards, you can just say, like right here, so this is pick p.x and p.y, and you would have the same, that would be eloc, and then eloc.x, eloc.y. It might be a little bit too much at this point to like go back and retroactively do all of that, especially if you're like, you've mentally already constructed it with the 0, 1 index model. But it's a nice thing that they've recently started, it's recently started becoming pretty trendy with Python studios.
Yeah, I can see how that would be pretty nice. Yeah, so we could.
You can revert if you want back to the old 0, 1, if that's easier.
I could see the semantic value of doing it this way, but I mean, you know, if we're.
I wouldn't blame you. It's kind of like a brand new like wrench to kind of throw into it. So if you wanna just keep it as it was, that's totally fine.
But I mean, so here we are again. I mean, the first location, so the 0 is referring to the rows and the 1's location to the columns. Okay, so we're back where we started, and here we have the position of the board, of the empty location here where we're swapping to, and then we're changing the position. We're updating the position of the empty location. We're returning the updated board and the updated empty location. Here we're checking if the move is legal. So basically we've checked if adding x or y to the x and y components of the empty location exceeds or like goes to an index that doesn't exist, we don't want to do anything. So maybe we just return the board and the location as it is.
Guys, are you planning about explaining advanced concepts in Python, things like decorators, comprehensions, generators, in one of your future streams? You guys have a great teaching skill. First of all, thank you very much for the compliment. We would definitely like to do more advanced Python streams. Veronica is, per what Bavik Knight said, doing a stream in the near future on more, well, the stream is called 100 Cool Things in Python Part 2. We already did Part 1 where we covered about 40 different small things. We'll probably do that again with a future stream. No concrete plans on all of those necessarily, but doing a more structured, advanced Python stream would be pretty fun and pretty cool, so we'll definitely take a look at doing that. So thanks for the suggestion.
Now that we have this general move function, I'm trying to go ahead and update these to look how they should. So if we know the move function is returning the updated board and location, we'll also want to return whatever this returns. And now we'll have to change the x's and y's for this each time. Okay, so moving up, that's subtracting 1 from the row. Moving to the right is leaving the row alone, adding 1 to the column. Moving down is adding 1 to the row, leaving the column alone. And then moving left is leaving the row alone and subtracting 1 from the column. So in theory, we should have a working way of moving here. Okay. So now that we have this, we can probably update in the main.py file what happens when we release the key. The only other thing, though, is that even if we override this behavior to actually make the moves, we are only ever printing the board at the beginning of the main function, so we wouldn't actually see anything change. So we might want to write a function for the board that just kind of like refreshes the terminal screen and redisplays it. Something like def refresh. And for this, actually, if we remember what the terminal looks like when we were, writing the left key, the down key, the up key, it would give us a little echo. So if we actually import up here from OS, let's import system so that we can clear the terminal screen programmatically. That way we get rid of whatever it was previously and we can just see the latest version of what we have. We can have in the refresh method that we're going to write, we can have the board class programmatically clear the terminal screen so that in the onPress, instead of printing hello, every time that we press anything, whoops, let's put this here just for my sake. Okay, anytime that we press the key, we will call the refresh method so that it'll clear the terminal, get rid of any echo that the terminal is going to display for us, and then here, after whatever we do, we're also going to call the refresh method so that after we press up or down or right or left, it will redisplay. So what this will do is it will clear the screen, and then we'll want it to display the board itself. So we already have a function that prints the board, so we can just print self. All right, and maybe what we can do, since, yeah, this is probably sufficient. So here we have, after we release a key, we're clearing the screen, printing the board. Whenever we press a key, we're clearing the screen, printing the board. I guess we don't need to listen to print this here, but we'll leave it for now. All right, and now the only thing that's missing is actually writing the moves to the keys. Okay. All right, so here what we'll want to do is we'll want to, if we take a look at what our move function does, is it returns the board and the location. So what we'll want to do is call, and so does this return the board and location. So we'll want to say b.board, comma b dot, and it's actually kind of confusing because I named this empty location. So let's just have this be the same name so I don't get confused. Okay. So b.eloc. This is going to take the value of calling b.move up, and it's going to take in the board, the empty location, and I think that's all that it needs. Yeah, because we took care of the rest. All right. Just for incremental testing, let's see what happens when I run this. All right. And eloc is not defined. Haha, perfect. Where do we have eloc not being defined? Oh. Where is here? I named this just loc instead of eloc. So I'm trying to use a parameter that doesn't exist. All right.
That'll mess you right up.
Now we actually have the parameters named properly, and here I actually specify the right names, I believe. Okay, let's try this again. All right, so we noticed when I press enter, the whole screen was cleared, and now we just have the board. So it's the center of attention. Okay, there we go. So we pressed up key, and we have been able to move.
Nice.
I'll press escape to quit so that we can finish implementing this in the other directions as well. All right.
It's a nice CLI interface, all things considered, too. Rather than having, like, you press a key to say, I want to move up, and it has, like, a menu or whatever, and then it, like, reprints the board below that.
I think the way
the CLI.
The way that the old pset in CS50 used to be was that it would prompt you. Do you want to move up, left, down, right? And then you would type it, and then it would reprint the board below that.
Yeah, exactly.
So it was kind of annoying.
A little more of a traditional way of doing it, I think, but also easier to understand because you don't have to go through like you know, refreshing the terminal, doing asynchronous input, that sort of thing, right?
We can actually take a look at what it looks like if we don't refresh on key press. So if I, you know, if I just don't include this, I think pass keyword makes it do nothing.
Pass keyword will do nothing, correct?
And so up is up, right is right, down is down, left is left. Okay, so if I don't refresh the terminal, we get something like this.
Ah, okay. Oh.
Where every time that I press a key, you see like down is B, up is A, left is D, and then right is C for some reason. Okay. So the terminal's always printing this if I don't clear the screen on key press. So that's why I wanted to just preemptively do that so we could avoid that. And also, obviously, if I don't clear the screen here, so actually, let's just do this. Let's get rid of this comment now. And if within the refresh method itself, I don't clear the screen, and we run it.
Wasn't the CS50 Game of 15 asking for which number you wish to move? There's only one empty field on
That's
the board.
true.
So there's no ambiguity.
That's what it was. Which number did you want to move? And so the way this one is going to work is you just press with the arrow keys. You know, you move the empty
I like that
timer.
because it's nice. You don't have to think too much about.
And you can do it more quickly as well.
Yeah, much more quickly.
And here we're not refreshing. We're not clearing the terminal, so we get all this junk, right? So that's kind of a headache. So that's why we want to go ahead and clear this anytime that we press a key, so that we don't have to see, oh, which key did they press, and also like what did the previous board look like or whatever. Okay, so far so good. And just to confirm that we have the behavior that we wanted to. You know what? I don't like that. I don't like how when you run the program, pi main, you have that kind of like visual thing where it like the prompt was there and then the board and then it was gone. So at the beginning of the main method, let's just go ahead and instead of printing b, let's just call b.refresh.
Nice. Okay.
Okay. So now as soon as we run the program, it'll clear everything. Okay, that looks better.
That looks better. Yeah, that's nice.
We should probably have something like, I don't know, it seems kind of lonely. Let's say something like print welcome to the game of 15. And maybe that'll look a little more friendly. I don't know. Okay, we should probably put a space in between.
Yeah, probably. But it's nice little touch. If you were really pro, you would have like game of 15 and like big ASCII art at the top.
Yeah.
You can get I think there's websites where you can copy and paste ASCII art. If you like type it in, they'll give you a text string you can copy. That'd be pretty cool.
So we essentially have a workable version right now. If I'm at the leftmost corner and I keep pressing left, nothing's happening. If I'm at the rightmost corner and I keep pressing right, nothing's happening. Same if I'm down and I'm pressing down, nothing's breaking.
Nice.
And if I'm up, okay, so.
It's boundary locked.
So far so good. We're locked into our board. We can't move outside of it. We can make moves. So nice. We have basic board function to make moves. You know what I didn't write in the things that we need? We need a way to randomize the board.
There we go. Yeah. Because then you're going to start off every game and it's going to be solved.
It's already solved.
Yeah.
Okay. So that seems like a good candidate for another board function or board method. You know, functions and methods are essentially the same, except methods are functions inside a class. I think that's the distinction. So what I alluded to at the beginning is a way that we want to randomize the board such that it's solvable is we want it to start from a solved configuration and then make, you know, n number of moves to randomize it.
Right.
So let's make another pseudo constant here and call it like shuffle magnitude or something. And just to keep it simple so that, you know, I can at least still solve the game without having to play for a considerable number of times, let's just shuffle it like, I don't know, 10 moves.
One time.
Yeah, we have a 50% chance of starting in a winning move because it can move to the right or down.
Well, yeah, you could do boundary constraints on your shuffle such that it wouldn't consider it a shuffle if it tries to move outside of the bounds. But
yeah.
For the sake of simplicity.
I mean, if we just make it, you know, if we make the magnitude large enough, that I don't think it'll really matter.
Choose down 100 times.
What are the odds, right? Okay, so we have the constructor, the printing. Let's just, I don't like how it's all blue. I'm kind of like weird about some things. Clear the screen and print the board. There, now it's a nice little separator. See, now I'm thinking about it. Now I got to do it for all of them, you know? Represent the board. And then here.
There are some streams where I don't even comment my code because I just completely forget to do so. I try to be better about it, but just get a linter to remind you of that, says M. Kloppenberg. Yeah, that's a good point.
Checks. Let's just say makes legal move.
The linters that are integrated into the text editors too, I can get one for, I think you can definitely get one for Atom in VS Code. It'll actually show you on the left side of the screen in your file here if you have issues. You can do like PEP 8 linters, and you can also do like syntax linters and things like that. It's pretty cool.
Okay, so we want this shuffle function method that randomizes board using succession of legal moves. So that way we know for sure that it's going to be solvable. All right. We'll probably need the random library, I guess.
Yeah.
So let's go ahead and import that. Was it like from A, B, C, D, E, F, G, H,
I think you can just import random.
No, I like having them alphabetized, right? Wait. Harvard student doesn't know the order of the alphabet. Does R come before or after O?
Comes after O.
After O. Aha. See? We're just human. From random, import random.
I would say because English is your second language.
That's true.
I'll give you a pass, but Spanish uses the same alphabet, don't they? Same order.
Yeah, but it has some different letters.
So you don't get an excuse.
It's a total different thing, you know?
Maybe. I'll give you that one. I'll give you that one.
So from the random library, there's a function called randint that gives you a random integer, and I think we talked about this in your stream yesterday also, that you should generally seed your random number generator so that you keep getting different results each time that you run it.
Unless you want to test specific corner cases, but yes.
True. Good point. Okay, so I think now if we go back to our shuffle.
Rabin was asking, in Ruby the convention is that you write code such that you don't need to comment. Is there something like this in Python? As far as it goes, writing a lot of comments in Ruby is bad practice.
What?
It's a bit strange. I mean, I'm not too involved in the Ruby ecosystem. What I imagine they're probably referring to is writing self-documenting code in the sense that your variables are clear.
Oh, yeah. So, like, I mean,
function names are clear.
We could have named these anything, right? We could have named this like self.tomato and self.pear, and you know, it would have worked as long as we kept track of it. Can you tell I'm hungry? No, I'm just kidding.
Yeah. We just had some awesome curry katsu curry, which is pretty good. Yeah, I mean, I wouldn't go so far as to say don't comment your code at all in Ruby. I feel like that's kind of a silly convention, especially if you're writing an algorithm that's of moderate complexity. I don't think any amount of self-documenting code is going to make everything 100% clear. Like if you're doing, I don't know, like recursive maze generation algorithm or something in Ruby, I don't think there's any amount of variable naming and convention that's going to save a programmer from knowing exactly what's going on, not knowing exactly what's going on. So I would say don't worry too much about that. In Python, definitely use comments when they make sense, and I think this should apply to most programming languages. And I'll have to look into Ruby and see why they're saying that, because I don't know the ins and outs of the language quite as much as I know Python's as a language. But my instinct is that they're referring to variable names and some of their syntax that sort of makes it clear whether something's a Boolean expression or a Boolean function, like the question mark that you can use for function names and stuff like that. But yeah, I would say use comments, but make your variables and functions and layout of your code sort of obvious what's going on, as much as you can, right?
Bavik is asking, magnitude of 100 won't necessarily mean that we have to do 100 moves to solve the game, right? So yeah, I mean, you're completely right. The magnitude that I'm referring to is like how many moves are we going to make before we present the board to the user, so that it's at least not in the solved configuration.
It could theoretically be 0, because it could theoretically shuffle it and then shuffle it all back down, back to the beginning. I mean, it's not. Yeah, it's
like, I mean, in a shuffle magnitude of 10, it's not that crazy to think that they'll move up and then left, but then they'll move down and right, and they'll move up and then back down, and then by the end of the 10 moves they'll end up right exactly where you started.
I don't know how you would compute like just how many moves it would take from the that starting point, that 100 magnitude, because I can visualize like the algorithm kind of going back and forth, and like I could imagine there's multiple ways probably to like move the things to get it back in the same position if it's like kind of making moves in the same area. I don't know 100%, but I would imagine that it probably doesn't map anywhere close. Self-documenting code is code without comments. Code without comment. Wait. Self-documenting code equals code without comments I wrote. Nasty spaghetti code equals code without comments someone else wrote. True. True. Mathematically, the game must maintain its invariant to be solvable.
Yeah, that's why we don't want to just randomize the whole list of lists, because then we might end up with a configuration that can't actually be solved.
Yeah, that's true.
Okay, so what I was doing initially in the shuffle method is first I seeded the random integer generator, and then I thought to myself something along the lines of, okay, for 0 till however magnitude is, I probably want to pick a number between 0 and 3 or 1 and 4 and have that map to one of these functions, right? So like maybe getting 0 means you move up, getting 1 means you move right, 2 move down, 3 move left. Then I realized I probably needed some data structure to do that. So I'm going up here and I'm creating a data structure that does exactly that. So the nice thing about dictionaries in Python is that the keys can be anything. They can be like strings or ints or whatever, what have you. So I'm going to have a dictionary called moves, which is going to be like a dictionary of legal moves that I can make. And so if the key is 0, I'm going to have it be self.moveUp. I don't want to include the parentheses because I don't want it to actually execute.
Right.
I just want to kind of delay that.
You're using function pointers, basically.
Basically, yeah.
Yeah.
And then I'm going to have 1.2. And if you're curious about why I'm mapping like, you know, random numbers to these, it's like I think of up, right, down, and left as kind of like north, east, south, and west. And so just in my mental compass, I start up here and then kind of move clockwise. That's why I'm going up, right, down, left, 0, 1, 2, 3.
I go up, down, left, right.
So you go up, down, left, right?
Yeah, for some reason, I think it's because up, down go together and then left, right go together, and so I just say them
That's valid.
sequentially.
Yeah, for me, it makes sense to go in the cyclical way.
I can visualize that too.
Oh, I forgot to refer to the fact that this is...
Rabin, I might take a look at that style guide at some point, and then maybe we'll do a Ruby stream in the future too.
Self.move down, and then 3 is going to refer to self.move left. I cheated. Okay. All right, so that seems reasonable. 0 self move up, 1 move right, 2 move down, 3 move left. Okay, so now in the shuffle method, I've seeded the generator. I am going from 0 to whatever magnitude I wish, and then choosing a random int between 0 and 3. And now I'm going to have it do something like, let's see, self.moves.
It's 0 to 3 inclusive?
Yes.
Okay.
Self.moves at I, and now I want to actually execute it. Remember that move up, move right at all, take in the board and the location that we're going to update. So I'll have to pass in self.board here and self.elock. That's what I named it, right? Yes. Okay.
I agree with Andre saying comments aren't necessarily aimed at explaining what code is, but why it's doing it. Yeah, and I agree that no amount of self-documenting code can help with that. Like I said, you have to understand what's going on in the programmer's mind and their algorithmic sort of mental mapping, right? Like you could conceive of a problem abstractly in a way that's not even representative of any programming language construct, but you have to use the programming language to sort of create that. For like creating a data structure, using that data structure in a particular way, visualizing a problem in a particular way. The what versus the why, that's essentially it, yeah.
All I've done now is I've just made sure that the first thing I do is shuffle the board. So when we actually rerun this now, I have a key error, which is great. Not intended. So on line 48 in shuffle, key error. Oh, LOL. I did not mean to do I meant to do M. So what I was doing is I was essentially indexing into moves as long as the loop went, you know, from 0 to whatever. What I meant to do was each time that the loop iterates, M is going to take in, you know, a random value between 0 and 3, and that's the position that I want to index into. Okay. Boop. All right. So, I mean, obviously this is randomized in some way. It doesn't look super random because it's only 10 moves, but if I do this like, you know, 1,000 times, whoops, then that definitely looks more shuffled.
Yeah.
I don't really like that the blank space is starting kind of anywhere. Like it's fine, right? We know it's solvable, but it just like aesthetically, I like the idea of it starting in the bottom right corner.
Sure, yeah.
So I'm gonna do something that's not really necessary per se, but
you like move the underscore to the bottom right, no matter where it is.
And so obviously, I don't want to just swap its location with whatever substitution 3.3, because that could potentially break the solvability of the board.
Right. Yeah, you have to actually move it there the same way you would do it physically, right?
So I'm gonna just, at most, if we run this again. So at most, I would have to move it down 1, 2, 3 times. And then let's say it started up here. I would have to move it 1, 2, 3 down, and then 1, 2, 3 to the right. So we could just write.
You're just going to call or you're going to call move 3 times to the right, 3 times down.
Yeah, so for I in range, like max number of column or rows, I might just do self.moves. Down is 2. Self.moves at 2. Self.board, comma, self.eloc. And then I'm going to do the same thing, even though it's syntactically the same thing, semantically, just thinking, now I'm going to move the columns, and right is 1, up, right. And
so this is kind of like the what versus the why, right? Like this is a good example of why comment would be useful here. Like you know exactly what's going on here. I mean, well, roughly speaking, it's a little abstract, but it's like you don't maybe understand the reason for why they're doing this, and so somebody in their comment would be like, we want to make sure that the underscore starts at the bottom right every time for aesthetic purposes. Like, I don't know how you're going to communicate that necessarily with just pure syntax. Like, that's a human sort of aesthetic desire more than anything else. So yeah, that's to Andre's point. I think that's an example, a good example is to illustrate using comments that are based on the why, not the what.
Right, and even, so I've worked as a TF for CS50, and I had to grade code, and so previously, we have graded on correctness, design, and style, where correctness is, does the program work? Style is like, is it formatted properly? Does it contain any sort of comments at all? And design is, how efficiently was it written? Some design systems that went into it. But one of them is like, how useful are the comments, right? Because the comments could just be cluttering up the code if they're meaningless. And one of the things we say is, if you're writing a comment, don't just restate what you can clearly read in the code itself. Tell us like what the decision-making process was behind. Like why are you doing this? So I could have easily written a comment here that says, make 3 moves down, make 3 moves right. That's just kind of restating this. But what I'm doing here is, optionally, I just want to, or maybe for aesthetic purposes, move the empty space to the lower right corner. So even though the code is legible, you might be like, okay, why? But the comment says, oh, this is what the person that coded this wanted.
Right, you got to know what the programmer is thinking when they're writing the application, so that you can get into their frame of mind and understand the problem they're trying to solve.
So now we see that the board is shuffled, and we're starting in the lower left corner. If we run it lower right corner, yes. English isn't my first language. So.
Yeah, left and right,
Okay, great. And just, 3 times is a pattern. Is that the saying?
What is it?
If you do something 3 times, it's a pattern. Or like if something happens 3 times, like once is an accident, 2 is a coincidence, 3 is a pattern, something like that. I don't know actually if that's a saying in Spanish or if that's a saying in
English. Is that a saying in Spanish? I
have no idea. I don't know. Okay, so we're making some good progress here. We have managed to randomize the board. So all we have left is a function to solve the game and a game over screen. Solving the game is going to be a little bit annoying, I guess. So we can leave that last, unless we kind of do like a temporary kind of like cheat, where we say, hey, def solve self. All we're going to do is say like self.board equals deep copy of self.goal, right? Like this is kind of like a dumb way to solve it, right?
Hey,
right now. Or if we do this. Oh.
It'd be cool if over you could have a timer that just kind of like does the moves individually for the solve algorithm or whatever.
Well, what I am hoping to, I think we'll have time, is I want to write, so instead of having this cheap kind of like cheating solve function, is replace this with a breadth first search algorithm that will search for the correct path to take and then solve the game for us. I think we'll have time to do that because all we have left is check game over screen. And
oh, did you type self.board with an ed? You know what they're saying? No. Oh, they're saying self. I think they're
self.board.
Yeah. I'm not sure if they had it. If you had written that as a typo or something.
I guess I can check. Well, I mean, Python will tell me, right, if I'm referring to a variable that doesn't exist.
If you're assigning it to something, though, I wouldn't consider that a syntactical error, right?
Let me control b.solve.
Or if you're assigning something to it, it would just consider that a new variable declaration.
No.
Okay.
I think they're trolling.
Cool. I think they might be trolling. Thanks for the troll, Bloomberg. Appreciate it.
Okay, so we are going to test now. So I've just arbitrarily mapped the solve function to the shift key. So now let's see if we rerun this and press shift. Okay, so we have solved the game.
Good job.
All right, so we probably now, it'll be a lot faster to just implement game over than solve. So we can do that ideally by checking whether the goal is equal to the board somewhere. So I'm thinking we can have it be, let's see, let me refer to my notes here. Something that we do pretty often is refresh. So, okay, here's the thought. Here's what past me thought of. We can have it check, since we know that the last thing in our main function, right, is the keyboard listener. If we want the program to end, we have to return false. We have to give this kind of like signal to the listener, return false, like, okay, stop. So what we can do is, since what we always do is refresh every time we press a key, we can include in the refresh method a check for whether the goal is the same as the board, and then have the refresh method return true or false, where if kind of, counterintuitively, if the game is over, or like solved, you return false so that the listener quits. Otherwise, you return true so that it continues. So let's do that. Okay, let's go to refresh here, and let's have it do this. After it welcomes you and clears the screen and everything, here let's just check something like if self.goal, which is the original list of lists that we created, if this is equal to self.board, return false so that we terminate the listener. Otherwise, just return true. Okay. Yes. And here now what we can do now is just return refresh. Or if you return true to this listener, it doesn't do anything. So here what we can also do is just return b.refresh. Wait. What am I doing here? Oh, if the game is over. Here. Return b.refresh. Actually, I don't think I need to do this here. I think this would be sufficient, right? Okay, let's try this out. And now if I solve, okay, it's done. So we might want to give it like a congrats, you won type of thing. So here we'll say, if the board, it's kind of like more intuitive for me to ask the question the other way around. I don't know why. If the board is equivalent to the goal, print congrats, you won.
Nice.
And maybe like separate it a little bit from the board. And then we fire that message. And here
then we'll end, right?
We will say py.main.py. If we solve it, congrats, you won. Game is over.
You could test it like manually too. If you were like, to only do like 5.
Yeah,
maybe
let's
3 shuffles or whatever.
Let's bring down the shuffle magnitude to like 5. It's very likely that we'll have to rerun it a few times in case we automatically win.
Yeah.
Yeah, like see, we just already.
It doesn't quit there. See that?
Oh, that's interesting.
So there's a slight bug.
But that time it did.
Oh, did you rerun it?
Yeah, I just did. This time it didn't.
Okay, I'm not sure why that's the case.
This time it didn't as well. Interesting.
Looks like most of the time. Are you sure you reran it?
And look,
okay,
that time I reran it and it did quit. That's so strange.
Yeah, that is a bit weird. And it's doing it every single time too. Like you're winning every time, almost.
Let's increase the magnitude.
Oh, are you hitting shift?
I only no. I was just.
Okay.
Oh, was I? I was hitting shift. Was I? No.
I don't know.
I don't remember.
All right. Well,
the chat will tell us.
Now you can try and solve it, right? So.
It'll be funny if I can't, right?
I mean, it's not an easy game to do, right?
Congrats, you won.
Okay, so we know it works.
I'm pretty sure that wasn't the optimal way to solve it.
Probably
but,
not.
Okay, good. So our game over screen is working, right? Now we will implement a more robust solve function that uses breadth first search. So maybe people in the stream might not be familiar with breadth first search. Maybe we need to talk about that first. Solves the game using BFS algorithm. Let's just pull up a tree and talk about it. Binary tree. Maybe it doesn't have to be binary. Search tree. Search tree. Okay.
It's a little hard to see in the chat or in the stream. So.
How's this?
Oh, that's good. Yeah.
Okay. So this is just for those who are not familiar with search algorithms. The purpose of them is if you're trying, in the context of maybe like AI or something, if you're trying to, like for example, in our game, let's say this is the state of the board, and we want like an artificial intelligence to solve the game for us. It's going to take this initial kind of screenshot of the game, and then it's going to have to search through different possibilities that it could foresee if it makes certain moves. So obviously, the AI would have 4 possible moves to make here. It could move up, left, down, or right. Obviously, if it moves down or right, it's not going to do anything, but it won't know that until it does it and sees the new state of the game. Mm-hmm. If it moves up, we'll have something like this, and then this will be like a new possibility, and from here it can move up, left, right, down again, so on and so forth. And so in the context of a search tree, we can model the game as a tree, where the root, which is the very first element in the tree, is the initial starting point of the game. And then instead of having only 2 directions here, maybe it has 4 branches, one for up, down, left, and right. And then if it makes a move up, it's at this new state of the game where once again it's faced with, it can move up, down, left, right. And so you can envision this tree with 4 branches each time, progressively getting larger and larger. And so the way that breadth first search works, so pretend that our goal state is the 7. At some point down the line, it's going to get to a point where the screenshot of the board is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whatever. Let's pretend it's the 7. The way that breadth first search works is first it checks the root. Then if that's not the goal, it checks, this node. Every kind of like circle in this tree is called a node. It's going to check this node. Then it'll check this one, and then if neither of these are the goals, it'll move on to the next level of the tree and check this, until it checks this, and then finally gets here. That's opposed to another algorithm called depth first search, where it just goes all the way down one branch. So like, let's say the AI says, I'm going to move up. And it's going to keep, going down that like path in the game without even considering what would have happened if it had moved to the left as its first move. Then once it reaches the conclusion, which actually might be really, really long if, you know, in the original state of the game, all you have to do to win is move left for some reason, or move up or down. But if you move in a different direction, you have to like do a bunch more moves or whatever. So depth first search could potentially take like a really long time if it goes down the wrong branch. Whereas breadth first search is just going to be like, okay, I'm going to try moving up. That wasn't the win. Let me try moving left. That wasn't the win, so on and so forth. So we're essentially going to just be kind of traversing a tree level by level as opposed to branch by branch.
To that note, Bavik had said, does breadth first search always take fewer steps than depth first search?
No, because what if the goal was
number one or whatever?
Well, in this example, it would be, but we can draw, right? I like going to this blank slate, and then it's for typing, but I have some. So like, oh, this is an old thing that.
It would be funny if there was like something like really blasphemous.
No, I don't. I don't condone blasphemous activity. Erase all. Okay. So
there's also draw.cs50.io, which.
Oh, really?
Yeah. Oh, but you have a touchscreen too. That's sick.
Yeah.
I didn't know that this was a touchscreen tablet.
So if we can imagine kind of like a tree where you have like a really long branch and then maybe like a lot of other branches per level, right? And then these each had like a lot of branches, whatever, blah, blah, blah. Using breadth first search, you would have to search this one, then 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 this one, this one, this one, this one, until you got here. Whereas if you use depth first search, you would just whoop, automatically get to the end and be like, oh, that's it. But by that same token, if the goal state is over here for some reason, depth first search would look through this branch, then it would look through this one, then through this one, then through this one, until it finally got here, whereas breadth first search would check this, and then find it. So depending on the
tree is set up.
On the way that the tree is set up, one is faster than the other. So I just arbitrarily was like, okay, let's just use breadth first search to search. Okay.
Blue Booger had mentioned that Red Blob Games website has excellent tutorial on pathfinding and Python and game programming. I think I actually checked out that website a long time ago when I was getting more into like procedural generation algorithms for like roguelikes and stuff. They have, I think if it's the same website, they have a lot of really cool resources on that. So yeah, definitely check that out.
All right, so let's give it a crack. Let's try to implement this, right? Where's my editor? Here it is.
Oh, Baka and Grow, you guys should add a description to your stream. Yeah, that's a good point. We should. Thank you for mentioning that. I'll do that soon. Are you guys just two random dudes doing Python tutorials, or what is this? Yeah, so this is so CS50 is a course at Harvard that has a YouTube channel and Facebook and all this stuff, and we're kind of an extension of that. We're based at Harvard University. And we have access to a bunch of people here that all know a lot of stuff. So Rodrigo is a CS student here at Harvard, and he whipped up this Game of 15 problem set from a prior year and is doing it in Python. I do game programming. We've got David J. Malin, who hosts, sort of lectures CS50 and sort of mans this ship, so to speak. Does a whole bunch of other stuff. So yeah, definitely check us out. Watch some of our prior VODs. Go to our YouTube channel, youtube.com/CS50, if you're curious about our lectures and whatnot. It's a lot. We do a lot of different stuff. So we're just kind of new to Twitch, so growing our presence on this platform. Also,
I want to touch on something that I just saw someone write in the chat, where, let's say we have an example. So the comment was from Andre. Andre, breadth first search is exhaustive, and it will certainly find the shortest path. So that's a good point. Say we have, like, especially in this type of game where you have multiple ways of arriving to like the same state, right? Like earlier, do I still have an example here where I could have, probably gone left, up, and down, and won the game, but I went in the other direction like a few more times and finally won it. So we have multiple ways of getting to the same state. Some of them will be shorter than others, and so let's pretend that we have multiple goal states. So maybe square is the goal state. And so we can win the game either by making one move or making 3. So depth first search will find this solution, which is potentially longer. But breadth first search, since it goes level by level, it checks every node at each level, so it will inevitably find the shortest solution. Whereas depth first search might find another solution, but it might be longer, for example.
Okay.
And there are certain what's it called, possibilities where one branch might go on indefinitely, and so depth first search never checks any other part of the tree or something. So yeah, another note about breadth first search is it'll find the shortest path to victory. Okay, good note. Okay, so what we're going to do is, since this is going to be probably a more lengthy function, is we're going to map it out first. We are going to write what we're going to do. So we want to have, one thing that we want to avoid is getting stuck in some sort of infinite loop where we make say we want to remember states we've been in, right? We don't want the AI to start off at some starting state, make a few moves, end up right where it was at the beginning, and then check the same moves that it had checked before, and then get stuck making the same pattern over and over and over again. So we'll probably want a searched list where we can store configurations that we've been in before. We'll also want what is known as a fringe, which is essentially kind of like a queue of nodes that we are waiting to check out. So like in the tree that I drew out, if in the first level there's 4 different nodes, so going up, right, down, or left, we'll want to just put those in the queue for things that we can do, and then check those one at a time. So we'll want to actually make this a queue, and we're going to need to import from Q. That is after, no, that is before R, right?
Q is right before R.
Yeah.
Q, R, S, T, U, V, W, X, Y, and Z.
So we're going to import, LOL, we're going to import the Q class from the Q library, and we're going to have our fringe be a Q. If you wanted to do depth first search, I think you would use a stack, because then it's last in, first out, right? But anyway, let's not go down that rabbit hole. So we're going to use a queue to do breadth first search. And I wish I would stop erasing. Here, we can use this tree. If we use a queue, the way that we do this is we're going to check the current node. We're going to say, is this the goal state? If it is, we can just break out and return the path that we took to get there. If it's not, we want to check its successors, right, or its children.
So is every node then just a copy of the board, basically?
Essentially, it's like a copy of the board, and we're also going to want to store the current path that we've taken to get there, so that at the very end, we can return that path and then make those moves.
Okay.
And that way we can actually visually see the program solving it step by step instead of having
this could get pretty large, couldn't it? If we're adding a copy of the board every node every time we make a move.
It'll get large, what's
the total memory? Have you measured the memory cost for 1,000 shuffled boards? So
I was actually messing around with that earlier, and I originally, before I did this, I had it the shuffle magnitude set to 10,000, and so I was like, oh, man, I'm pretty sure I wrote this correctly, but it's not returning anything. And then I was like, I should print, all the nodes. And so I just see for minutes it's scrolling all this different stuff it's thinking. So I lowered the magnitude to be 5 moves, and then it just solved it pretty quickly.
I wonder if you can discard prior, set prior nodes of the tree to nothing because you're caching the path, and have that still work. Would that work?
Yeah. So that's what we want to have this searched list for that I have initialized here, so we can keep track of things that we've seen before, such that if we see them, we don't look at the successors. We just stop looking at that branch altogether.
Right.
And that should help. Okay, so we want to keep track of states of the game that we've seen already. We want to have a queue of nodes that we're going to check out, like moves that we can make from the current position. And then we want to have a root for the tree. So like the initial starting point is going to be whatever the current board is.
Right, yeah.
Okay, so now what we want to do is add.
Are we using the queue to represent the tree? Well, that's just the current level of the tree, right? The search or the fringe.
The queue will hold all of the. So like in this example, what we'll do first is we'll add the root to the tree to the queue. Then we'll pop it from the queue, check whether it's the goal node. If it is, we'll return. If it's not, we will say, okay, if we haven't seen this state before, go ahead and add it to the list of states that we've seen. And then after we do that, we will find its successor. So we'll see where can we go from here. Then we'll store all of its successors in the queue.
Okay.
And then for kind of repetitively for each new successor, we'll be like, okay, we'll pop the first one. It's FIFO. Queue is first in, first out. So this one will be like, okay, we'll pop this from the queue and we'll say, is this the goal state? And if it's not, then we will, check its successors, add them to the queue. But then since it's a queue, we'll move on to the one that was added after this one.
I see. So it'll never. So what's hinging on making this work is we will never ever see the same state again while we're solving.
Right.
Like otherwise, this would be impossible.
Yeah.
Okay.
That
makes sense.
We will use this list to keep track of things that we've seen, so we don't get stuck infinitely making the same pattern of moves, never making.
I wonder how much that I could see taking a lot of memory too. Like how much memory do you think it takes to like store every possible permutation of the board? First of all, how many possible permutations of the board are there?
So let's see. We have 16. Is it like 16 factorial? Or
I don't know what it would be.
Because it could be.
Because I don't know if you can, strictly speaking, get. You can't get every possible numerical permutation on here because it has to follow a pattern. Like the invariant has to stay consistent.
True. Yeah. So less than
earlier.
16 factorial.
Yeah, it would be less than that, but I don't know what the number actually would be. But it's interesting.
I'm sure we can. It's a quick Google search. How many possible configurations of game of 15?
Or 15 puzzle. It might be known by 15 puzzle more frequently.
I can't type. How many different possible combinations are in the 15 puzzle?
You place in the blocks in a frame.
10 to the 13.
Ten to the 13. So okay, so there's 10 to the 13 board positions. Those are all strings that are 2 bytes each, right? So this is interesting. So now what I had the instinct to do is to hash all the potential positions, right? To take that data structure, that list data structure, and hash it, and then store the hashes in a dictionary. And that way you can immediately check to see whether that hash exists in the dictionary, right? Because how are you checking prior positions now? Are you just going over every single one of them and comparing them? Is it with equals? Equals?
I'm saying like if, current board not in search list.
Okay, so you are doing equals effectively. Okay, that's what essentially.
That's probably why it takes so long for larger as it gets longer.
So what you can do is you can hash, if you hash those lists, right? That data structure, find a way to hash it and deterministically get it to hash. You could store them in a dictionary and then do a constant time lookup of that.
Dictionary is your constant time, right?
Roughly constant time lookup, yeah.
So
that would almost be
and actually
very fast.
If we if we used a set for the searched instead of a list, that would be searched is constant time lookup in Python, I believe.
And a set? Yeah, it is because they hash it underneath the hood, yeah.
So we could use a set instead of a list, which I have to remind myself.
But can you? I don't know if you can. Well, I guess you can hash. That's what I'm saying. The tricky part would be finding a way to hash a nested data structure like that deterministically. That would be the tricky part.
Something we could do is you
could turn it into a string and then hash that string. because the board is always going to be a different string, right? You could literally just make a string of the board as it is laid out with
like
brackets.
1, 2, 3, 4.
Yeah,
or whatever.
with the brackets. Because then you would ambiguously have 11s and stuff like that too. So if you do that, if you flatten your list into a string with the brackets, you can hash those strings. Those you can then store in a set, or you can store them in a dictionary, but a set would work fine as well, and then you get almost constant time to look up for those.
And so the only thing that we're going to be changing in this algorithm is how we are representing the searched list, right?
Yeah, searched is no longer a list; it's going to be a set, and every time you're looking at a brand new set is not indexed. Be aware of that.
That's fine. We won't need to check indexes.
What was I going to do? I was going to check to see what 10 to the 13 was. 10
It'll be
to the 13 is equal to...
more than a trillion.
That's a big number. Yeah, that's like, what was that? 1,000, million, billion, 10 trillion.
10 trillion.
So you could have 10 trillion different
Here's what I'm thinking.
Lists.
Here's what I think would be fun.
That you're doing an if statement on in your thing. Well, I mean, and is that potential? That's just for the 15 puzzle, right? Yeah, that's insane.
Here's what I think would be fun. Let's implement it using a list. See like at what point it starts getting really long. Then change the search list to be.
We could time it. Yeah.
Yeah, and then we could just.
That would be sick. Yeah, let's do that. Yeah.
Because we'll have like a working version, and then once that's done, we can mess around and see how much of an impact we can make just by changing the search list.
Yeah,
that sounds fun.
That does sound fun. That sounds
okay, so like we were saying, we want to have some data structure in which we keep track of all the states that we've searched. We want a fringe to be keeping track of all the different moves that we want to try, and we want to kick off the tree with a root. So the root is going to be the current board. And now what we want to do is we want to add our root to our kind of like tree. So the way that I wanted to do this was making a dictionary where we're going to have a couple things. We're going to have the board that we're keeping track of, and that's going to be the root. Then we're going to keep track of the empty spots location. That's going to be the current empty spot location. And we also want to keep track of the path that we've taken to reach the current state. So at the root, we're going to have the current board. I guess I don't need to write this out as its own separate variable, right? Okay. So originally, now this is the root, because the node isn't just going to be the board itself. It's going to be kind of like a struct containing some information. We're going to store the current board, the current location of the empty spot, and then the path that we've taken to reach this node. The root node, we've taken no steps to reach it, so the path is just empty. And here it doesn't matter whether we use a list, because we're only going to be adding like some small number of moves to get. We're not going to do like more than probably a couple hundred moves to solve it, I don't think. I'm sure this is solvable in a few number of moves. Okay, so now we're going to kick off an indefinite loop using while true. This is where we're actually going to start searching the tree. So the first thing we want is kind of like a base case that we just want to quit if, and let's just write this out so we know what we're doing. Quit if no solution is found, which we should never have to worry about, but in case, this is important to write when you're writing it for the first time, in case you accidentally introduce a bug into your code and then your algorithm doesn't work. This way at least you break out of the loop once the queue is empty. So if fringe.empty, and the fringe is just a native Python queue, and so instead of like enqueue, dequeue, and what have you, the methods are put, empty, and I think get. So this checks whether the fringe is empty, and here we're just going to return an empty path, like nothing. Okay, so that's kind of our base case. So now what we're going to do is we're going to dequeue the current node from the fringe. So node is going to be fringe.get. Get is the queue function that will return the current first element in that queue, and we'll put it in this node variable. All right. Now, and so let's write out the algorithm. Inspect current node. All right, now we want to check, is the current node the goal state? So quit if node contains goal. All right, here we'll check if node at the board position is self.goal. We'll return the path that that node contains. So ultimately, what we want the solve function to do for us is return like the list of steps that we need to take, the list of moves that we need to make in order to solve the game. So if we find that the board in the current node matches the goal board, we're just going to return the path that is attributed to that board.
Hey, how's it going?
We have David joining on the stream.
Guest.
Nice to see everyone.
So we're doing a game of 15 in Python. Currently, we're on the solver right now. So we talked about it earlier. We're doing a sort of like a
Breadth first search.
breadth
So we're hung up on that. Why don't we do a depth first search?
Yeah.
Well, don't worry. Earlier, I was asking Colton what order the alphabet is in. So there's that.
Oh, did you go with alphabetical?
I tried to, yeah.
Nice to see everyone, though.
We're doing an
Looking forward to seeing
interesting. We're
this.
doing an interesting experiment. So right now we have basically this whole algorithm hinges on checking prior states of the board because the board can only ever be in one state at a time while we're solving it. Basically we can, instead of assembling this massive list of prior states and checking to see if we've already seen that state, we can hash the state of the board as a string and store that in a set, and then do a constant time lookup of that hash string, and see how that comparison actually ends up, how much time we save.
But first, we're storing everything in the list to see like what the difference in time is. If we start off with a list versus something that's going to have constant time.
Because this list is going to be massive, especially if we've done 1,000 steps to get to the permutated board.
But you're just using these hashes to determine if it's in a one configuration.
If we've encountered this state before while we're going through the actual algorithm of.
At which point you're memoizing the answers.
We are, exactly, yeah.
Oh, okay. Okay, that's good. I was a little nervous there because if you pre-compute all these hashes, that's like n factorial.
Oh yeah, no, it's like 10 trillion different ones. Yeah, no, we would not do that. Actually, just looked it up on a calculator right there to figure out the exact number.
Oh my god, I have to think about where to put the commas there.
Yeah, nice.
All right, well let me leave you to it. But good to see everyone. I'll hop on the chat and looking forward to seeing this develop.
Cool. Thanks for hopping over.
Alrighty. So far we have dequeued. We have dequeued the root from the queue, and we are inspecting whether it is the goal state. If it is, we are returning the path that it contains. Otherwise, if it's not, we want to add the current node to our search set, which right now is a list, and then put its children in the fringe. So if the root node isn't the goal, we want to add it to the list of search states that we've seen, and then we want to put its children in the fringe so that we can repeat this process again with them.
Right.
Okay, so the way we're going to do that is we're going to check if node board not in search, which is what we're going to change later.
I mean, it's still going to be not in search, right? Because you're doing it you're going to look in a set, though.
Yeah, we're going to change what search looks like, which will dramatically...
Exactly. This will actually be pretty much identical.
Which is nice,
yeah.
Which is why something as simple as what data structures you're using can completely change the runtime of your code or the efficiency.
Oh yeah, 100%.
Okay, so we're going to go ahead and append to the searched list the current board that we were seeing.
Also, it's funny that Asley was lurking this whole time. So glad to know that you've been in the chat, Asley. And everyone's saying hi to David. If you use Dijkstra's shortest path algorithm on a graph with all the edges at the same weight, it just becomes breadth first search. Yeah, I don't know too much about. I have to reread up on Dijkstra. It's been a long time since I looked at any of that stuff.
All right, so now we're going to want some function to extract the successors from our current node, right? So let's just pretend that we have a successors function right
Are
now.
all the successors going to be up, down, left, right from that one
Right,
node?
yeah.
Right, okay.
Okay, so for child and successors, which we have to write, successors doesn't exist right now, we're going to say if the child, I don't know, now we're getting the territory where we haven't determined the behavior of successors yet. So actually, let's just go ahead and define it so that, for child and successors, we want to check whether one of those children is already in the search list, so we don't add it to the queue. Otherwise, if the successors of the current node isn't in our search set, we will add them to the queue. Because say, for example, that we're starting at the lower right corner, and this is the result of moving to the right. That would be exactly the same as this one. So we don't want to even consider this. And so that will save us the time of putting this in the queue. So we will skip this and go to the next one, which may be like go up or something.
Okay.
So let's define a successors, maybe like a helper function within here itself, within the solve function.
For anything to understand most of the things this guy is saying. No, it's okay. I mean, we've gotten into a little bit of algorithmic territory, and I'm not even that good at algorithms and data structures. I've learned a few things over the years, and I should study upon it a little bit more in detail. But this is all good stuff to kind of be aware of, just like using the right data. Take that away from the stream, if anything. Use the right data for the job. Try to look for, when you're manipulating data like this and doing thousands upon thousands of potential iterations, and all of those things take up data, that's an opportunity to optimize. And as I totally understand, I have off days as well, all the time. But thanks for tuning in nonetheless and being around and still absorbing the material. That's really like a huge thing, and that's something I think that's important, especially in like language learning, is just absorbing sort of passively, passive media ingestion, or at least in this context, like passive CS vernacular, and just kind of getting input, input sources. It's super important.
All right. So for the successors function, we know that we're going to want 4 separate boards, because one of them we're going to move up, one of them we're going to move left, one of them we're going to move down, and one of them we're going to move right. So maybe not like the nicest way possible. I've made 4 copies of a board, and I've just stored them in a list. Same thing for...
How large is this queue going to be at max, by the way? Because we're popping off the queue every time we check something, right? Or are we just adding to the queue and never getting rid of the...
No, we're popping every time that we inspect a node, we're popping it from the queue.
Okay. So when we inspect 8, then we pop 8, and then we inspect 3, we pop 8 and add 1 and 6 after the 10 in this case?
We pop 8, we add 3 and 10 to the queue, then
we go to 3, we pop 3, add 1 and 6 to the queue, go to 10, and then do that, and okay, I see, got it.
So at most, we're only ever having less than 2 levels of the tree.
Yeah, so it can get large later, but it's not going to be like insane.
Yeah. Nice. Okay. So, blah, blah, blah. E-lock and E-lock and E-lock. So, as I kind of referred to earlier, deep copy helps for recursively copying a list, but if you're working with a shallow list that's only 1 level, you can make a copy just by using the list function in Python that gives you a list. And okay, so now what we're going to do is we want to say, like, for example, and we can clean this up later, but for now, just...
I wonder if even here, instead of deep copying, like using the hashes, like sorry, I didn't mean to do that.
Sorry.
Using the string hashes, because all you're doing, eventually when we do the new algorithm, right? Like these, all we're doing is we're just comparing these ultimately to what we've already seen in the thing, right? And comparing it to board, but we can have a hash of the board as well, right? The solved board.
True.
The goal.
The only thing though is that we actually need to make a move. We need this is the current state of the board, and so we want to see what it looks like if we move it up, right?
Yeah,
so
you're right.
The only way we can make a move is if it is an actual
unless you wrote a function that could take the hash and do it on the hash.
Yeah, that would be a little bit more work, I think. Okay, so here what we want to do is say self.move up, and we're going to have this be the same. We're passing in the board to the move up function, and we're passing in the location of the empty spot to the move up function. So we'll have this be here. All right, and let's clean this up later, but for now let's just do this for the other ones, just because I want to have time to mess around with the other ideas that we've had. And this one will be moving right, this one will be moving down, this one will be moving left. And here we have 0, 1, 2, 3, and 0, 1, 2, 3. Yeah, a loop might be better for this. Okay, and so now what we'll want to return is, this is going to be the children. So we'll want to return potentially a list of lists, where here we're going to contain the board, position 0.
Bakken Grow, thank you very much for the follow. I think I missed somebody else. What was it? Apologies. Kake Knos, thank you very much for the follow as well. Much appreciated.
So I didn't talk about how I want to, what's it called? I didn't talk much about how I want to represent the path list, and the way that I want to do it is have it be with numbers like we did before. So 0 means up, 1 means right, 2 means down, and 3 means left. So that's what I'm doing here. I am returning, as the kind of like children, I am returning the current board if you move up, or in whatever direction, the current location of the empty spot if you go in whatever direction, and then what direction you moved in as an integer. So here I'm saying board if you move up, empty location if you move up, and the fact that we moved up.
Right, because that's the information that represents the path we took to get to that actual thing, because we're going to return that eventually. And how are you returning that? Is it just going to be a data structure that just gives you the list of directions in order? Given the
yeah, it's just a list. So the path will look something like, I don't know, 0, 3, 0, whatever, up until it solves the thing. And we'll see. We're just going to iterate over that list, and kind of how we shuffled the board. We're just going to loop through all those results and refer to this dictionary up here.
It'd be cool if you got the end result of that, and then you had the starting state of the board, and then like a function that like performed every step every like 200 milliseconds or whatever, so
we're
you can watch
that.
it. Oh, okay, that's good. That's cool.
Okay, so now we know that successors is going to take in a board and the location. So node at board and node at eloc, which I think is what we called it. Yes. And what is it? Why did it change the colors here? I'm curious. Did I close down this list? Wait a minute. This list here closes that, and then this closes. Interesting. I think I have some extra brackets that I don't need. Okay, so now this is closing that. This is closing this. This is closing that. This is closing this, and then this is closing that. Okay, that looks better. All right, so now we know that the node is going to take in, that the successor takes in a board and the location, which in the node we have a board key and a location key. So now the child is going to be a list containing a board, a location, and then the direction. So we want to check if we've not seen the board in the child. So if child is 0 not in searched, we will add that child to the fringe. So we will put in the fringe a dictionary containing board, and then have this be child at position 0, and then elook is going to be child at position 1, and we're going to have path be, here's where we got to remember the parent's path. So it's going to have to be the path of the current node plus child at index 2 in list form, so that we can concatenate these lists. So I'm doing essentially something that looks like, if I have x is a list containing 1, 2, and 3, x plus 4 will give me 1, 2, 3, 4. And so that's how I'm going to update the paths throughout the tree. So this might be like the current node, and then the children is going to be either 0, 1, 2, 3, and so we're going to add it as a list to the existing path. And that's what is going on here. All right, so now I believe this should return to us the path to victory. So what we got to do is check in our main function, where we have currently right here, if we press shift where it's going to solve, we want to store the path. So we're going to potentially store this in a variable called moves, and if we want to be really fancy, we can print something like thinking, because it might take a few seconds. And okay, so we're going to have the path right here. We know that we have to return false when we want to stop when we want to quit the program. So I'm going to preemptively have this variable called persist, which is true, because we're going to want to refresh the board with each move that we make. So we want to keep refreshing such that we're returning true, but once it's done, we want to quit the program. Actually, do we need to do this? I don't think so. Okay, let's just do this. Let's say for m in moves, so for move in the moves that we need to make to win, we're going to refer to the moves dictionary that we have in the board right here.
Shout out to Brenda, by the way, for joining the stream. A little late, Brenda, you are right, but that's okay. Like everyone is saying, better late than never. Glad to have you with us. We're getting to the really cool stuff here in a second when we actually compare running time of a sort of, I would say, naive implementation, just caching prior states of the board in lists and strings, and then memoizing them per when David walked in. That was a much better word than how I was trying to describe it.
So after we make a move, we'll want to refresh the board, and then we actually have to import from the time library, import sleep, so that we can have the terminal sleep for just a second, so we can actually see the move being made, right? And then it'll finish doing this, and it'll return refresh. Okay, unless we miss something, let's make sure that the shuffle magnitude isn't too big. It's just 10 right now. Okay, let's see what happens if we run main. We automatically won.
Nice.
Okay, so here it is shuffled a little bit, right? And if we press shift, it's thinking.
So it's not in this case showing you a like live figuring out the solution. This is, it knows the solution, and then it's doing it. It's actually doing the one solution that it
right.
found.
We could also print the solution list, but I mean it would just look like numbers, so the user wouldn't really necessarily know what it means.
Right. Yeah. Yeah. Now this is super cool.
But you'll see now that if we increase the shuffle magnitude to say even, I don't know, 20.
Does it get a little bit lengthy? I mean, we can get rid of probably the.
Oh wow, that was quick. But I don't think it shuffled that much. Some of the moves must have been. Actually, it looks almost like the same the same moves. That was a big coincidence.
That's pretty funny, yeah.
All right.
This is a little bit shuffled.
Yeah, so now, like, all of a sudden, it's thinking a bit longer, and we can start to play around with changing the searched data structure from a list to something a little bit faster to search. So something with constant time lookup or near there. Because, I mean, already you're kind of looking at this like, oh, man, once again.
Yeah, it's thinking. It's thinking for a while.
Okay, so while this thinks, do you want to...
Yeah, let's do the memoized solution, because that sounds like it'd be way faster.
So here we are. You were recommending using a set, right? So I actually,
set. I originally proposed dictionary, but somebody recommended set, and that actually makes more sense because all we're doing is seeing that it's inside of a container, right? And they all are unique, just per virtue of what they. I mean, I guess it doesn't matter in a dictionary be the same way, but set sounds like it'd be fine.
It's on sets.
But what we need to do is we need to serialize the string, or well, I don't know if serialize is the right word, but we need to take the representation of the list, stringify it, and then use that as the hash or the index into the set. And we need to make sure we preserve the brackets in that string, just because like you could have a situation in which you have maybe like, would this be the case necessarily? Yeah, like 11, 12 versus like 11, 2, 3, 4. Like it doesn't know whether that's 1, 12, 3, 4 or 11, 2, 3, 4, you know? So you do need to keep the brackets in there to preserve ambiguity in certain situations,
right.
I think. So let's definitely do that.
Okay. I was just refamiliarizing myself with set notation.
Oh yeah, yeah. A lot of the data structures all have kind of a uniform interface, just because like I forget what they call it. The Python, like they have a term for it. Like all the core like dunder functions they define that let you have similar behavior across data structures. You can like define them yourself.
Okay, so let's say we have a set based on this list. If we want to add elements to it, I think it's s.add. Like if we wanted to add 4. And then we can say 4 in S, and that's true, but 5 in S should be false. But if we do s.add 5, and then we do 5 in S, okay.
Yep.
And then s.empty potentially is a function? No. Don't remember how to check.
You could just say S is equal to set.
No, I'm checking if set is empty and
if it is empty.
But I don't think we actually do this in the algorithm.
No, I don't think we do. No, you're only doing that with the queue, right?
And I believe you can have S2 just be an empty set, right?
Yeah.
Okay. And
say you construct a set
is empty.
Yeah. You can also construct it there's another way to do it, I think.
Okay, so now we have searched as a set, which means here instead of search.append, we'll have search.add, and we'll have to change the representation of what we're adding.
Yeah, so node board is going to have to be equal to the string, or just the string of the representation of the board.
If we have a list of lists, like 1, 2, and then 3, 4 here, if we do stir b, that seems sufficient.
Yeah, that seems pretty good.
Okay.
You're going to get some, the extra bytes don't matter actually, yeah.
Let me make sure we're not using...
Yeah, so you could just do a string of node board there.
Right here.
Yeah.
Yeah. Stir node board. And that means the actual node contains the board, which is good in case it needs to move it up and stuff.
And I think you need to do if string node board not in search there too, right? Fuck, sorry, I keep doing it.
Yeah.
Oh, I just cursed on stream. Sorry.
That's okay.
Bleep. Bleep.
It's all right.
That was that was a slip.
All right. So if node board as a string is not in search, and same here, if the string format of the child is not in searched, let's see. Is there really anything else we got to do here? I don't think so. Board. Yeah, I don't know. I think that's it, right? We just changed them all to strings and put them in a set.
I think so.
Okay, so let's try
Curious how much to think. What was the number that you set it to before when it had to think for a long time?
The one that we did on string?
We just did, yeah.
I haven't changed it. It is at 20.
It was 20 and it was taking that long?
Yeah. I remember that the first one was pretty quick, but it's because I think the shuffle was nicer, like closer to a goal state.
Wow.
So let's...
Is this thinking right now?
No, I was like, wait, did we already win? But no, it's 9, 11, 12. Okay. Wow. Okay.
Yeah, that was fast, instantly. Okay. So if we keep bumping it up.
Let's see if we do...
So to be clear, we just took the algorithm, the breadth first search algorithm, and we changed it from being sort of, I guess, not linear search, not like, I guess linear search in terms of looking at the data, but we brought it and made it into a set, I guess. So this one's slow. What was the number that you used on this one?
Here it's 40.
Okay.
So it's thinking, but I feel like it hasn't yet reached the number of the amount of time that it thought for the one that was 20 when it was still a list.
Wait, what?
And if you look at this board, it's actually decently shuffled, right? It's 5, 1, 7, 3,
oh, yeah.
2, 10, 6, 4, 9, 14, 12,
Yeah.
8. So it's not like for the other ones.
It's finished now, though.
It's done now. Yeah,
that was still reasonably
and that
fast.
was 40 shuffled moves, right?
Yeah.
And so we can even just see how long it takes it to solve it to kind of get a sense for how many moves it's been having to make.
So it'd be cool to do like a, that wasn't even that many moves, but I mean,
Sure.
it had to go through the tree and figure that out.
But breadth first search always finds the shortest path to victory.
Yeah.
So I wonder if we kick this up even to, I don't know, 80?
Oh man, that's gonna take a long time. I feel like it'd be cool to do like a time before and after, you know, like to see.
True.
Because it feels like, I mean, 40, it solved it in a fraction of the time it took
To solve it for 20.
to solve it for 20, yeah. So I'm not sure what it would be, like how much time we've actually saved, but it's clear that we've saved a lot.
Yeah, we've definitely saved some time. I mean, I guess for comparison, if this, you know, doesn't take forever, we can put it back to a list and see that it basically never finishes, right?
Yeah, you could do like a 21. Spartan GTR, thank you very much for following.
What have the people in the chat have been saying while we've been doing this?
There's some conversations going on amongst people. I haven't been
Because this is a perfect time to talk to the chat now while this is thinking.
Yeah, true. So we shouted out Brenda for coming into the chat. Talking about Coursera courses, and then some folks left. Oh, Bavik was saying print the number of the steps and the length of the path, so we can see actually how many times it's doing it, right?
True.
Because that'll help us get a better idea of just how long the algorithm is too.
So clearly, even with making this a string in the set, this is 80 shuffled moves is still...
It's still a long time.
Yeah.
Yeah. I'm sure we're saving a tremendous amount of memory though.
For sure.
Because like if you were thinking about how much memory you need to store for like those lists of lists,
yeah, that's
that
true.
was probably a lot.
A string would take less for sure. Yeah.
Well, a hashed string. It's not even a string that's being stored.
True.
It's a hash of a string.
Mm-hmm.
Yeah, O of 1 versus O of n, clearly, yeah. Not quite O of 1, but the actual, that's the lookup of the hashed string, but the actual depth or breadth first search is still going to take a long time.
Yeah, this might be, you know, a little bit too much for it.
Veron is saying this is just some magic.
It is cool though to like just sit back and then watch it figure itself out, right?
Yeah.
But yeah,
it'd be cool if you could have a counter here. You could keep I mean, I guess that would slow the application
it would really,
down a little bit.
like anything where it has to do with printing while you're in a loop is going to really slow it down. That's why I waited to do the searching first, so it's as quick as possible, and then do the refreshing the screen after it's figured it out.
That makes sense.
Because I mean, we could have like an updated counter, but then that would just
that would skew the performance a little bit, yeah.
But I mean, other than that, that's the game of 15 that I had ready to present.
Yeah, no, it's great. It was cool. It was cool that we got a chance to actually go into like algorithms and data structures a little bit, make it a little bit more theoretical, and like actually apply it to something. Sorry, stretching a little bit. But yeah, no, it was awesome.
We can probably even see.
Oh yeah, and they're saying if you can push it to GitHub, they want to actually get a chance to tinker with it. If you
Oh yeah, I actually already have in my GitHub the let's go to my profile. My GitHub is Rodrigo17.
It's a good name.
I already have the Game of 15 here as one of my repositories.
What's the link? I'll type it in the chat. So it's github.com. And this is without the change. That do you want to commit or maybe do a branch that has the memoized? I mean, I guess it's easy enough to make a change on stream.
I mean,
yeah, just do that.
All I had to do was put stir in the 2 places the 3 places. Oh, and we changed it to a set, so it's not too bad.
Yeah, that's not bad at all. That's something that if the viewers are going to tinker with a data structures based.
If you follow that,
algorithm,
does it get to it?
It should. Yeah, let me check and make sure.
Yeah, there it is.
Is it public?
Yeah, everything that I do is public.
Cool.
Yeah. So
everything except the private things that you do.
Well, the only things that are private are things that I don't own.
Gotcha.
But yeah.
Still thinking, geez.
I don't know.
I mean, even if it does finish, we won't know how many moves it took necessarily without watching the whole thing.
Yeah.
So yeah, that's unfortunate.
But if it does finish, the fact that the stream is recorded and then people can go back and watch it means that if you're really curious, you can skip to whenever this finishes thinking and then actually count. But yeah, I don't know.
That was awesome.
Is there anything else that people in the chat want to talk about while we, wait this out? Or if this takes too long, we may just have to.
Yeah, we might cut it short here if if we don't have any questions and it takes a bit longer. But that was awesome. Thanks for coming onto the stream and putting this together. It was cool. It was fun for me to participate in. I don't do a lot of algorithmic programming, at least more on the academic side. So this felt like an academic exercise, which is cool. And I liked the fact that we kind of took a jump and dived a little bit more into analyzing the performance of the application and figuring out ways to do that using just simple data structures, not even really going out, not even changing the algorithm, just changing the fact that we were using a set instead of a list of lists of lists, right?
It would have been interesting to see like how much longer it takes using depth first search or something.
Yeah.
But one thing at a time. I mean, I'm hoping to be back on the stream at some point in the future.
Yeah.
Classes are about to start next week, so I don't know what that'll look like for me. But if I end up doing something for one of my classes that I think is cool, I can kind of take inspiration from that and do something in a similar spirit.
Yeah, let me know, and then we can get you back up. And I know that you're always game for if we play some Super Nintendo or something.
Yeah, if there's games.
Yeah, or NES, because you seem to be pretty into those. You were there for both of those. So, M. Kloppenberg saying maybe an algorithms stream or something. I mean, it would tie into this a little bit.
Yeah, it would be. We could talk more about different types. I'm actually about to take algorithms classes because that's what I'm mostly interested in is in algorithms. I do enjoy coding, but the part of coding that I enjoy isn't the looking up the syntax and getting the syntax right? It's like the actual problem solving portion.
Yeah, that's the most important thing. I mean, there's tremendous. I wish this actually was more of a dramatic change in performance. I mean, it might be ultimately. It might be a dramatic change in performance, relatively speaking, and it's because it's just so much that we haven't actually seen it through. We'd have to time it and we'd have to see. Like the 10 versus the 20. Or
if someone in the chat is very into this, they could time this using the list version, which is in the repo, and then maybe it won't be much trouble for me to add an additional push, having it be a set and then the string, and then compare the two afterwards, and then let us know next time or something. But yeah.
That'd be awesome. Am Qualberg saying your water looks like it's boiling. Green screen magic. Maybe.
I only like drinking 212 degree Fahrenheit water.
Yeah, boiling water. Bella Cures, our pleasure, Bella. Thanks for tuning in. And to M. Kloppenberg, and thank you, Babik, for the kind words. Appreciate it. Vrani, thank you. A few minutes is Babik. It's taking a little bit of time. Tomorrow we're going to be taking a look at Render. Is it Render 50? Yeah, Render 50, which is a PDF tool. So take source code files, and a lot of text editors don't really let you print or export to PDF from your text editor, but what we needed was a way, I mean, David especially needed this for lecture, to be able to print source code and be able to look at it while giving lecture, have it nicely formatted on the page, and a few other different cool things. And so just using Python, previously the tool was written in PHP, but we took it, we made it in Python, and completely redid it. And so we'll have a little bit of look at that tomorrow. So we're getting more into the Python stuff, which is cool. Today was Python. Veronica will be on stream in the near future with Python as well, and I'm sure we'll have other folks that are on stream for Python-related content. Maybe
and the stream tomorrow is at 3, right?
Oh yeah, the stream tomorrow is at 3 p.m. It's not at 1. So 3 p.m. Eastern Standard Time, I'll push a event notification. It's already on an event on the Facebook page, but I'll post another post to kind of pub it, and then it'll go on, you know, Reddit, Twitter, etc. You'll see it. Tune in. It's going to be a good time. David is going to be hosting that one. David J. Malin. Yeah, going to be an excellent time.
Just be a dramatic time for it to finish, but I don't know if it will.
Yeah, I don't know if it will either. It's going to be a long time.
It'll be like the end of Inception, you know, where the coin is spinning or the totem is spinning, and you don't know if it's going to stop, and then they end it.
Well, it looks like we have a little bit of content that we can keep going off of. So Bavik says your Ubuntu looks dope. Oh, M. Klappenberg, you're right. I don't think we officially ever confirmed the time at 3, and so I kept it as a draft. But it'll go up tonight for sure. And then I guess when I make it an event, I'll post it to the Facebook group and all that stuff. And then I'll also start creating events for next week's streams. We have a few lined up for next week as well. That's going to be a good time. Kareem next week is going to do Flask. I'm going to do CSS next week. David and I are going to do code reviews next week. Minesweeper. It's going to be a good week next week. Yeah, it'll be a good time. I was going to look at, what was this? Bavik was saying, your Ubuntu looks dope. Which desktop are you using?
As in the Ubuntu version? Or?
Yes. I guess the Ubuntu, and if you have a graphical window manager or whatnot, like what you're using for that?
I'm on 18.10 Ubuntu, and I'm actually, ironically enough, I'm not like a computer person, right?
Oh yeah.
So like
that's okay. A lot of people have this, I think, stereotyped perception that all CS people are also like computer technicians.
It's definitely something that I want to improve on.
Yeah, I think it's definitely valuable. I mean, if you like, computer parts aren't really hard at all to understand or to use, but I mean, like troubleshooting hardware issues, I think that's something that takes a lot of experience and training and stuff. And so CS people usually do, or you're familiar with the software side. The hardware side is not really something they necessarily have to interact with on a daily basis.
But I do notice it's 18.10, and I had to configure my bash RC to have it look the way my terminal look the way it does. But other than that, yeah, I'm not too knowledgeable about.
That's all right. No one's going to hold you accountable for that, I don't think. This was an awesome stream. Appreciate it again. I like, part of me wants to like keep trying to prolong it just so we can see if it finishes, but
it'd be funny if as soon as we cut the stream,
yeah,
it ends,
starts,
right?
Yeah, that would be pretty funny. Yeah, as our pleasure. Franny was excited to see it finish. Franny, you should take it and run it yourself. Clone it off of GitHub and try it out, and then see, maybe time it. Use the time function at the command line or whatever on a Mac or a Linux. I'm not sure what it is on PC.
The current version is still using list for the searched.
Right. Yeah. So you'd have to switch it to the set version in order to see what that performance difference would be. Yeah. Franny says, too bad it's too late. Maybe I'll watch the VOD, referring to tomorrow's stream. Yeah, definitely watch the VOD. All these videos go up onto YouTube. I'm going to very tragically transition us back to the full shot here. We're going to say that maybe this won't actually finish by the time stream is over. Oh, apologies. Oh. Beast Chris turned in too late today. Don't worry, the video is going to be on YouTube. So it'll be on YouTube within a couple hours. You'll be able to watch it in its entirety, as all of our videos are. And what I was going to say was, if you are watching this on YouTube, you can tune in to CS50's Twitch channel on twitch.tv/CS50TV. Every week we have programming videos from scratch. I do game programming. Rodrigo came in today to do some Python. David's going to come in tomorrow to also show us some Python stuff, and more, I guess, to talk about making applications using pre-built software, because we did use a lot of libraries for that application. But yeah, a pleasure as always. Thanks everybody who tuned in today. We'll catch you tomorrow at 3 p.m. Eastern Standard Time with David for Render 50. So thanks again, Rodrigo, for coming in.
Thank you for having me.
Much appreciated. We will see all of you later. Have a good rest of your day.